Hello, I'm Brian Nickel, and today I will be covering the basic concepts of Dr. Walt Brown's hydroplate theory. I say basics, which may imply we can cover this quickly. Unfortunately, I found that brevity only leads to misunderstanding, so I'll explain in depth as much as possible to ensure the basics are not simply covered, but that the foundational supporting evidence and science is understood. To understand the theory, we will need to cover multiple areas of study, some of which are well known by the general public, and others that may not be. First, let's cover the flood passage recorded in the Bible. It is an account which many find hard to believe, and for good reason. Most have not studied the passage closely, and fewer still have established a working explanation which correlates what we see today with what Genesis says occurred. The flood seems impossible under the light of casual observation, which leads most to conclude it was not global or is pure myth. We'll briefly discuss the text and context of the flood in Genesis, and we'll then look at Walt Brown's hydroplate theory, which I've found to be by far the most scientifically in-depth explanation of what truly was a cataclysm, or in the Greek, katakludzo, which is the very word Peter uses in 2 Peter to describe the Genesis flood as a cosmos or worldwide event. The account of the flood in Genesis chapter 6 to 9 brings up some difficult questions. Many struggle to answer these questions without deferring to miracles or concluding that the passage is not to be taken literally. These unsatisfactory answers lead to a certain ambivalence about the importance of this account. Many have concluded that the flood passage is of little value other than a spiritual nugget that following what God says may be a good idea. However, if patient and willing to consider some out-of-the-box ideas, the Genesis account becomes much more than a bedtime story, but a foundational event of history that validates the Bible, its New Testament authors, including Jesus, who will all refer to Noah and the flood as historical. This touches on my purpose for presenting this series. My aim is that the information covered here would give both Bible skeptics and believers pause to evaluate their assumptions about what they think they understand about the flood event. Many times believers of the Bible have a blind faith which places them in a position of having little to offer to a skeptic that would help them to see why the believer objectively trusts the Bible's account. This can lead to a heated discussion that frustrates both sides because the blind faith believer bases their argument on because God said so. This may be a true statement, but it is not going to convince someone who is skeptical of the Bible and God in the first place. For the skeptic, I think many see right away that their scientific education completely contradicts the Bible's account of origins. This becomes the basis for rejecting most of the Bible as made-up stories. Why believe in any part of a fairy tale that most agree didn't happen, right? And it follows that if the Bible's historical records are make-believe, why trust in anything it says about who God is or our moral accountability to Him? I hope this presentation can help show that the Genesis flood account actually fits modern scientific observation better than the evolution model that we've been almost exclusively and sometimes dogmatically taught. If the hydroplate theory can show that Genesis gives a very real account of the flood based on scientific principles that matches our observations, then perhaps the rejection of the Bible's historical record should be reconsidered. And if the Bible's history is in fact real, then a re-evaluation of who God is and our accountability to Him should take place as well. If correct, the hydroplate theory rewrites our scientific understanding of Earth, and therefore we'll spend most of our time focused on this first question. It is not easy to answer, and I find it requires time both to discuss and to digest. Many times questions have hidden assumptions. Notice this second question assumes that all the fountains of today, including Mount Everest, have always existed. Other questions seem to demand a miracle. 40 days and nights of Geshem rain or heavy downpour rain has never been observed. Either this did not happen, was a miracle, or we incorrectly assume that today's hydrodynamic cycle is the source and don't fully understand the real mechanism behind all this rain. The next two questions are more readily answered once the assumptions hidden in question number 2 are exposed. We too often assume that what we see today existed during Noah's day. Because most fail to identify assumptions, it becomes attractive to reinterpret the most natural reading of Genesis into something less than what it claims, thereby making it more believable to our minds. It is certainly much easier to reword a Bible passage than to rethink everything you have come to assume is correct. So does the local flood idea really fit the context? The Hebrew word for earth, Eretz, can mean the entire earth, land, ground, country, etc. Some try to force this passage to mean just the land or country, to support a local flood theory. However, due to the context of the passage, the local area idea must answer the following difficult questions. Were people outside the area considered righteous? Why not just move Noah, who was given 120 years warning ahead of time? This is what God did with Lot. Was God only grieved that he made man and animals in the local area? Later in chapter 9, the flood is claimed several times to have destroyed all flesh that breathed air. How does any local flood wipe out all birds? Our recorded observance of local, even very large floods does not at all match the record of events in Genesis. This event is the most chronologically detailed and precisely recorded year in the Bible. This is strange if the story is just to promote a moral lesson. In Genesis, the flood begins on the 17th day of the second month of Noah's 600th year. This must have been quite a day for it to be recorded so precisely. As we'll see, that was the last day those 8 people would see the earth as they knew it. The world they would see next was completely unrecognizable and harsh. It rains continuously for 40 straight days. Then the rain stopped, but the waters continued to rise for 110 more days and cover all pre-flood mountains. A question needs to be asked here, and that is, how could the water rise after the rain stopped? Any flood theory needs to explain the mechanism behind this. 5 months into the flood, the ark comes to rest on a high peak, after which water levels can be observed to be decreasing. 74 days later, lesser peaks become visible. 90 days after that, the waters have completely drained, but Noah, his family, and all animals do not leave the ark, apparently because conditions are still too unstable. Finally, 57 days later, and after 371 days on the ark, they are allowed to leave. This detail in the context of Genesis 7 and 8 is telling of something much bigger than anything being proposed by any of the local flood theories, which all fail to fit this detailed chronological record of dated events. The constant rain is never explained by local flood theories. The Hebrew word geshem describes heavy rain. All local floods being proposed would have distant mountains clearly visible throughout the entire episode. No local theories explain 150 days of rising waters. No local theory mechanisms support a 304-day flood period, nor do they explain why the land would have been so unstable that Noah would not have been allowed to leave the ark for 57 days after the land looked dry. Even the trendy Mesopotamian and Black Sea local flood theories fail miserably to fit the Genesis account. At some point, just to be thorough, we should ask ourselves, is it valid to change and twist a record because it is hard for us to imagine or explain its details? Sometimes it is difficult to see alternative possibilities when we have been told what to think instead of how to think critically. Let's begin to answer the 5th question. Where did the floodwaters go? Realize our oceans today cover 70% of Earth's surface, and the average basin depth is 12,000 feet. So the volume of water we have right now is plenty to cover Earth's surface. In fact, 10 times more water is on Earth's surface than there is land above sea level. In fact, if the mountains and continents of Earth were bulldozed so Earth was flat, the volume of water in today's oceans would cover the entire Earth to a depth of approximately 9,000 feet. So while huge post-flood chains like the Andes, Rockies, Alps, and Himalayas did not exist, smaller mountains up to 9,000 feet could have existed and have been easily covered during the flood. So the problem is not that we don't know where the water from the flood went, because we can see it from any beach in the world right now. Understanding this then begins to answer question 4, where did all the water come from? Answering this will take much of our time. Explaining how the water ended up in today's ocean basins will take even more time, so we will have to be patient. Why do we assume that all the water on the surface now has always been on the surface? The problem is when we assume that everything we see now has always been that way. This fallback uniformitarian assumption is ingrained in our education system, but it is not always a correct assumption. I'd encourage you to research the life work of Harlan Bretz for a small-scale example of what happens when too many assume they are right simply because popular opinion is so entrenched. When someone asks how Mount Everest could have been covered by the flood, ask them why they assume Everest and all other mountain ranges for that matter were present at the time. Hydroplate theory makes few assumptions, but if you take time to understand it, you'll see it provides excellent answers to these and dozens of other questions. This is a cross-section of Earth's present state. No one has ever dug down to see this, and you'll see why we can't dig to the center of the Earth later. However, we know this layout exists by timing seismic waves from earthquakes as they travel through the Earth. Sound travels at different speeds through solid materials than liquids, and this is the rough picture of what is down there. There is a thin crust which sits on top of an 1,800-mile thick solid mantle. Then there is a very dense molten outer core that surrounds the mostly iron-nickel inner core. The liquid of the outer core is twice the density of the rocky mantle. Zooming in on a cross-section of the surface near the edge of a continent, we would see the following. Continents are made primarily of granitic materials. The granite continents rest on the mantle. The Mohorovicic discontinuity, or MOHO, is a boundary line between the crust and the mantle. Seismic waves travel much faster below the MOHO than above, for reasons that we will soon discover. Most of the surface of all continents are covered with sedimentary rock that averages about a mile thick. Sedimentary rocks are made up of finely ground bits of crystalline rock, like granite or basalt, that have been cemented together by a cementing agent like calcium carbonate. For example, sandstone and limestone are sedimentary rocks. Metamorphic rocks occur when sedimentary or crystalline rock is greatly compressed and heated. For example, marble and diamond are metamorphic rock. The two most prominent surface rocks are basalt and granite. The floors of the ocean basins are primarily lined with basalts, which are igneous, meaning formed from a melt state. We know basalts are igneous because we see them being produced in nature and can replicate basalts from a melt in a lab. Continents are primarily granites, which are slightly less dense than basalts. Contrary to what is commonly assumed, granite does not appear to be igneous, meaning formally melted. Rather than being igneous, granite would be better termed as an enigma. Granite is made of very large crystals of quartz, feldspar, hornblende, and mica. These materials have differing densities and melting points. If granite was molten for millions of years and slowly cooled as assumed, the differing liquid mineral densities would naturally self-sort due to gravity, just like oil and water. The result would be a layered cake pattern, not the large interlocked crystalline patterns that we see today. No one has ever reproduced large-grained granites seen in nature. The end product both in the lab and in nature when a granite is melted and resolidified is a plain igneous rock called rhyolite, which has tiny crystal grains like igneous basalts do. The borders and edges of continents taper and are beveled. The continents generally thin and taper out under the ocean's surface, forming the continental shelf, which runs out under the water between 300 and 600 feet deep. The true edge of the continent then rapidly drops off in a bevel shape to an ocean depth averaging 12,000 feet, forming the continental slope. Notice that the thinned continental shelf connects the continents. If ocean levels were several hundred feet lower, you could almost walk from Southeast Asia to Australia and from Siberia to Alaska. If this were the case after the flood, while much of the flood waters remained trapped on the continents, there was a good reason behind God's direction for survivors of the flood to spread out as they increased in population. This also may explain why in Genesis 9, Nimrod and those who settled on the plain of Shinar in today's Iraq were quickly confused by God with differing languages and thereby forced to spread out. This also explains why the origin of all language is tracked back to this region. About 2 generations after Babel, the earth was divided in the day of Peleg in Genesis chapter 10. Peleg's name is a root for many words today concerning water, like archipelago or bath pelagic. This lends credence to the idea that the earth was literally divided by rising ocean levels that separated the continents in the days of Peleg. I'll now give a brief general summary of how Earth formed from an evolutionary view. There are actually many differing views, but the following appears to be the most popular today. Supposedly 4.5 billion years ago, asteroids gravitationally collapsed into each other, and the energy released from these impacts produced a molten liquid Earth, which remained molten for millions of years. As accretion ceased, the surface eventually cooled and formed a solid crust, but as we just covered, a granite crust could not have originated from a previously molten condition, and no lab has ever been able to replicate granite from a molten state. The evolutionary model then states that over time, the remaining inner molten materials were gravitationally separated to form the dense solid inner and outer cores of the Earth. Note that any thermal analysis accounting for all realistic forms of heat generation and heat transfer predicts that the sphere of Earth should have completely solidified by now if it is actually 4.5 billion years old. This is one of many observations which strongly indicate the upper limit of Earth's age is much younger than assumed when relying on radiometric ratios. To further investigate the fundamental problems with radiometric dating, please refer to my other video titled Hydroplate Theory: The Origin of Earth's Radioactivity. Evolutionary theory of the Earth's origin assumes that the Earth remained in a molten state for around 200 million years. Naturally, any water brought by asteroids would rise to the surface and evaporate long before the Earth's crust solidified. A runaway greenhouse would have followed, trapping solar heat in the humid atmosphere and making life on Earth impossible forever. According to some evolutionists, millions of years after surface solidification, comets bombarded the Earth, depositing even more water on its surface. But recent discoveries of high deuterium concentration, or heavy water, on comets, compared to Earth's oceans, have led some scientists to conclude that Earth's water could not have come from comets. In summary, the evolutionary theories of how water came to be so prevalent on Earth's surface is not supported by what we observe today. But if we assume the evolutionary theory is somehow true, then basic scientific principles tell us that Earth's water should only be found on the surface. What is surprising from this evolutionary view is that there are unexpectedly large amounts of water trapped at depths far deeper than surface water could ever seep. Here is why deep water under continents is not expected. Imagine a block of soft modeling clay or Play-Doh. Now stack more blocks of clay on top. Eventually the bottom block will deform sideways due to the weight of the added blocks. Add more blocks and more of the material deforms. Now imagine that you have stacked another column of clay blocks very close to the original column. What will it do? It too will deform and compress against the other material. The dashed line represents the boundary at which the compressive strength of the clay or Play-Doh has been exceeded. Material below this boundary forms a tight seal. Even small microscopic cracks cannot exist below this boundary line. Take notice that gravity is the causal source of this condition. Even if surface water is poured into the gap or crack, it cannot seep below the boundary line. For clay or Play-Doh, this boundary may be only a few feet from the surface. You've likely seen a similar scenario after making stovetop pudding or cheesecake, after it cools in the refrigerator overnight. The semi-solid separates or cracks at the surface as it cools, but the crack is not very deep because the weight of the material slumps and closes the crack at a certain depth. Rock like granite has good compressive strength and can support a crack of up to 5 miles depth, but no deeper. In summary, assuming the evolution scenario, water from asteroids and comets collected on the surface before crust solidification, since granite's max compressive strength is approximately 23,000 pounds per square inch. No significant continental water would be expected below 5 miles depth. However, it is well known that deep water exists much deeper than this. Germany's KTB dig and Russia's Kola dig are the deepest man-made holes in Earth's crystalline continental granite. The goal of these digs was to reach the Earth's mantle rock, but neither succeeded. Both holes reached depths well below the 5-mile boundary of granite's max compressive strength. Both holes encountered unexpectedly extreme heat as depth increased. Even more surprisingly, they both struck saltwater-filled interconnected fractures in the granite. More recently, using conductivity measurements, a mile-thick layer of saltwater-filled sediments has been reported 10 miles under the Tibetan Plateau. In fact, deep saltwater appears to be a common trait under all continents. Hydroplate theory asks the question, if evolution theory does not predict deep water, then how else did the water get so deep under all the continents? At this point, it is interesting to note that the Bible indicates in several places that water was and is under the earth. Psalms repeatedly indicates this. The deep is in storehouses. The earth is founded upon the seas and upon the waters. The earth is spread out above the waters. Finally, and most telling, is the opening action of the flood recorded in Genesis 7 verse 11. The Bible strongly indicates large amounts of water were originally deep under the earth. The hydroplate theory uses these biblical descriptions in combination with many real-world observations we've just covered to derive its starting assumption about the original layout of Earth, which is radically different than what we see today, and certainly much different than what uniformitarian theory proposes. The assumed condition is that the Earth's surface crust was formed above a deep layer of water. This is a global condition wherein the Earth crust was an unbroken spherical supercontinent which covered and sealed in a deep layer of water trapped between it and the mantle rock. Many imagine that a combination of forces like the tidal pull of the moon, Coriolis forces, and centrifugal forces would somehow rip this shell apart immediately, and therefore hydroplate theory is invalid from its first assumption. However, few can maintain such a view once they compare all these forces to the dominating gravitational force of Earth. Although other forces are present, they can often be ignored because they are so small compared to gravity. There is a reason gravity is the first force we learn of in school. As we discuss the hydroplate theory's many observations, take note of how so much of the theory's explanation is simply founded upon the physics of what happens to materials under the influence of Earth's gravity. Rather than speculation about unconfirmed natural processes or imagined miracles, we'll see hydroplate theory turn again and again to Earth's gravity as the causal mechanism which drove processes and produced various effects. The Bible records further detail of these assumed starting conditions in the creation account of Genesis 1. The Hebrew for waters here is mayim, which is always used to describe liquid water. Many attempt to explain waters in verse 2 as if it is a frozen or gaseous vapor in space, but Hebrew does not use mayim to describe those states of water. Hebrew has many other words to describe ice, clouds, and vapor states, so clearly liquid water is in view. Then on the second day of creation, God said, "Let there be an expanse in the midst of the waters, and let it separate the waters from the waters." The word rakia comes from the root word raka, meaning to spread, beat, or hammer out as with a metal. It can also mean a plate. The Septuagint translates rakia with stereoma, meaning a solid, firm structure. The Latin Vulgate uses the term firmamentum, from which the King James translators coined the term firmament. The implication is that the expanse was a solid, firm material. Again, mayim is used in verse 6, so day 2 seems to describe a state where liquid waters from Genesis 1 verse 2 were divided in half and separated by a solid plate of material. Remember I said granite is an enigma and has never been replicated. Hydroplate theory proposes that this expanse material was a miraculous formation of a granite crust separating surface water from the waters of the deep. On the third day, Genesis 1 describes the results of God's further direction to firmly position the somewhat unstable expanse and bring it to a more stable equilibrium. Hydroplate theory proposes that the granite expanse was deformed at many points around the Earth, which settled into the solid mantle foundation below. Naturally, the thicker and denser portions of the crust would sink to the solid mantle foundation, but because the volume of water trapped below the crust was fixed, the lighter and less dense portions of the crust had to rise out of the water. This is exactly what Genesis 1 verse 9 describes when God says, "Let the dry land appear." The deformations raised the topography at the surface for dry land, and the depressions gathered surface waters, producing small seas. Again, Psalm seems to add further description that matches with this concept. Psalm 75:3, "It is I who have firmly set its pillars." Remember Psalm 33:7 said that God laid up the deep in storehouses. It is important to note that the pillars themselves did not support the entire weight of the crust. Most of the weight was supported by the pressurized water of the deep. With much of the water trapped under the crust, Earth would have had much more available landmass with many small shallow seas dotting the surface. Mountains would have been smaller than today. Hydroplate theory figures that approximately half of the water in today's oceans started out under the granite shelf, forming one giant supercontinent all around the globe. This estimate of the volume of water under the crust is based on the concentration of salt in the oceans today compared to what was found in the Bavarian KTP dig hole. In addition, water found in comets contains around twice the deuterium concentration that is in the oceans. The estimate also assumes that pre-flood seas were fresh water, which after the flood mixed about equal parts with this super salty deuterium-rich subterranean water, diluting it to the levels measured in the oceans today. I will describe more about the most likely origin of comets later, so hold on to this info, as I'm sure at this point it seems strange that water and comets would have anything to do with the flood or with the Earth. Hydroplate does not place an upper bound on the original volume of water in the chamber because there are some unknowns that have a large effect on the final answer. Today we know there are large amounts of water trapped deep in the porous Mohorovičić boundary layers, but we don't know by volume how much is down there. We also don't know how much water escaped Earth's atmosphere during the flood. Both of these unknown variables would add to the volume estimate based on the above concentrations of deuterium in salt. So for now, we'll just say the deep, or the Great Deep as referred to in Genesis 7:11, was a global interconnected subcrustal ocean chamber that was at least 0.9 miles deep at the time of the flood. Based on observations of current size and thickness of continents, hydroplate theory proposes that the original granite plate was 60 miles thick. If you've read prior editions of the theory, you'll notice that this has increased from initial estimates of 10 miles thickness. This change was arrived at after carefully considering the implications of several rather recent discoveries. Most recently in New Zealand, researchers have used explosives to generate specific short wavelength seismic waves to produce the clearest picture of what they believe to be a subducting plate. They are puzzled, however, because almost 50 miles down, a 6-mile thick channel containing melted rock and/or water has also been identified. This is not at all what popular plate tectonic theory predicts. For hydroplate theory, these discoveries are exciting because they are consistent with how a collapsed water-permeated subterranean chamber would be expected to reflect these seismic waves. The much slower wave velocities measured in the channel indicate magma and/or water trapped within the chamber's roof and floor. We will soon cover in detail how hydroplate theory explains these findings using cause-to-effect reasoning. This is the first strong evidence that the granite crust was in fact much thicker than previous estimates. Corroborating this is the growing body of evidence that trans-Neptunian objects, or TNOs, are most likely from Earth as well. We'll discuss this further later on. For now, we'll continue discussing the assumed initial pre-flood conditions. Remember, no cracks can exist in granite below 5 miles, so the perfect seal conditions we just reviewed existed to keep the surface waters from seeping down and, more importantly, the subsurface waters of the deep from pushing up through the granite. These are the basic starting assumptions of the hydroplate theory. From here, the theory uses only laws of physics to explain cause to effect, which we'll see provides reasonable and straightforward explanation of Earth's surface features today. This is a phase diagram for water. At atmospheric conditions, we see water freeze at 32 degrees Fahrenheit, 14.7 pounds per square inch pressure. As heat is added, ice melts and the temperature rises until at 212 degrees Fahrenheit, boiling produces vapor. The weight of 60 miles of granite above means that the Great Deep was pressurized to approximately 372,000 pounds per square inch. As will be seen, work was being done on the water of the Great Deep, which gradually increased its internal energy, so we will refer back to this diagram several times and see how conditions in the water changed and the dramatic effects that were produced. Just as the moon's gravity works to produce the ocean tides, the original granite shell would also have been worked and distorted by the moon's gravity. However, because it was a solid shell of great mass, the tidal effect on the crust was not as dramatic as with the open sea. Still, the crust would have deformed into a slight egg shape toward the moon. Obviously, the graphic has been exaggerated so we can see the distortions, and I've simplified the pillars to only 4 dark brown shapes, where the granite was pressed into the solid mantle. In reality, the global surface area of the relatively thin 60-mile crust would have allowed it to form pillars at thousands of locations. Twice a day the shell would have deformed, so the trapped waters of the deep were continually being pumped through the subterranean chamber at high pressure. This work added energy in the form of heat to the waters under the crust. At the same time, each pillar experienced tension, compression, and shear loads twice a day. Friction from these cyclic loads slowly heated the pillars as well. To get an idea of how these forces produced heat, bend a steel wire or a paper clip back and forth several times, then touch it at the bend. Now imagine how much heat would be generated at the extreme pressures in rock 60 miles deep. As tidal pumping continued, the pressure and temperature in the subterranean chamber increased. Eventually, liquid water changed phase into a state known as supercritical water. The hydroplate theory is not the first to recognize the possibility of a supercontinent. We all learned about Edward Bullard's Pangaea concept in high school. Few of us were encouraged to look at it critically, however. For example, what happened to half of Mexico and Central America? And what forces rotated North America clockwise, while South America was rotated counterclockwise? We also probably did not catch the fact that Africa's area is actually 35% larger than we were shown in the books. That's right, Africa had to be scaled down by about 35% to make it fit the picture. In fact, Africa and Europe fit poorly with the Americas when positioned in 3D on a globe, especially when you include the continental shelves that extend under the oceans and do not allow removal of materials as needed in order to force a fit. There is another feature on the globe that fits these coastlines much better. One of the key observations Walt Brown has made is that with an actual 3D globe, the coastlines of all four continents fit very well with the mid-oceanic ridge. Discovered in the 1950s, the ridge, which wraps around the Earth like the seam of a baseball, is the longest mountain chain at 46,000 miles length. The fact that this is almost entirely covered by water is not the only trait that sets it apart from today's continental surface mountains. As we'll soon see, the mid-oceanic ridge is a scar in Earth's mantle left over from the flood, which roughly traces the path of the crack that opened up in the granite shell. Surface mountains appear to be the result of compressed materials that have been piled up. This makes sense. Push compressed material together and it piles up. But the mountains of the mid-oceanic ridge are uniquely different than surface mountains. Tensile fractures show that the material has been pulled apart in two perpendicular directions. This is counterintuitive. How do you build a mountain chain by pulling material apart, in two directions no less? Hydroplate theory explains the unique conditions that produced this strange global geologic feature. We will discuss how this happened later, but first let's continue to investigate the nature of supercritical fluids, since it is key to understanding and grasping the magnitude and direction of energy released during the flood. The Genesis flood is not just an unusually long rainstorm as most imagine. As we'll see, rain was a readily observable effect of much more violent causes far below the surface. The waters of the Great Deep were the true source of energy. This energy was stored in and released from the supercritical water in several ways. First, let's discuss supercritical water a bit more. What is the supercritical phase? Boiling water will remain at the same temperature of 212 degrees Fahrenheit at atmospheric pressure. Apply more heat and it will simply boil more rapidly. However, the water temperature will not change as long as the vapor produced is allowed to escape. Place a cap on the container and both the pressure and the temperature of the water will now increase. Since all mass within the container is trapped, density of the vapor increases while density of the liquid decreases. Eventually, the density of the gas and liquid become equal. Microscopic droplets are suspended in the midst of the dense high-energy gas vapor. The potential energy stored in the water at this state is tremendous. The huge surface area of the droplets allows supercritical water to quickly dissipate added heat by evaporating all at once. Rather than increase in temperature, heated supercritical water, if allowed, will simply expand rapidly, converting heat into kinetic energy. Liquid water exposed to heat can only cool through evaporation off of its surface area. However, surface area of normal liquid water is limited and therefore the temperature of the liquid will increase because the surface area is small. Because the liquid surface area of supercritical water is enormous among trillions upon trillions of tiny droplets, supercritical water can evaporate many molecules simultaneously. If allowed, supercritical water will simply expand rather than increase in temperature. If more energy is added, the expansion accelerates. So that is some cursory information on supercritical water. But another form of energy stored in supercritical water was electrical ionization energy. So what is ionization energy? Under normal conditions in an open environment, occasionally molecules of a fluid will collide. When they collide with enough energy, the molecules will break apart into charged ions. This happens rarely with water in an open environment. A closed and pressurized environment forces molecules closer together, increases fluid pressure, and makes collisions more likely. Increasing temperature causes the molecules to vibrate faster. The closer proximity and increased movement causes more collisions. This causes ionization of the water. If pressure suddenly drops, the charged particles will rapidly seek an opposite particle. The sudden and multiple ion collisions back into whole molecules releases much heat into the fluid. Twice a day for centuries, the tidal pull of the moon, and to a lesser extent the sun, would have lifted and done work on the Earth's crust. This would have increased the thermal and ionization energy of the waters of the Great Deep, causing it to eventually become supercritical. Remember what happens when heat is added to supercritical water and allowed to expand. Supercritical fluids are studied today mainly for their great potential for dissolving minerals. The greatly increased energy of fluid molecules impacting against a solid will break up and dissolve the solid much more than would normally occur with less extreme conditions. Centuries before the flood, tidal pumping had heated the subterranean waters to a temperature above 705 degrees Fahrenheit, and the water became supercritical and began to dissolve the more soluble minerals in the chamber's floor and ceiling. For centuries, supercritical water dissolved the more soluble minerals in the granite and mantle, creating porous openings in the rock above and below the subterranean chamber. Once elements like sodium, calcium, carbon, chlorine, oxygen, and magnesium were released by the supercritical water from the solid structure of the rock and into the solution, they were free to combine, forming new molecules like limestone, dolomite, and salt. These minerals eventually precipitated out and heavily blanketed the chamber floors of the great deep. In the granite, this resulted in shifting of the embrittled material as tidal effects stretched and heated the granite pillars. Due to gravitational settling, denser trace materials like iron and nickel naturally collected in the lowest portions of the pillars of the crust. The porous region of the mantle that was dissolved by the supercritical water formed the density boundary today known as the Mohorovicic discontinuity, or the MOHO. In the oceans today, thick plumes of hot, supercritical water known as hydrothermal vents or black smokers are still escaping from the porous MOHO beneath the ocean floors in places. The high heat and pressure of the supercritical water still flowing from these vents shows that the flood event was relatively recent. In the years before the flood, as pressure increased in the waters under the crust, the compression which maintained the seal in the granite was replaced with tension loads as the pressurized water below expanded and began to stretch the crust. While granite has rather good compression strength at 23,000 psi, it is very weak in tension, only around 600 psi. Eventually it failed and a crack developed at the surface and in seconds raced completely through the 60-mile thickness to the pressing waters below. This crack raced across the crust, circling the globe twice in about 2 hours, covering around 46,000 miles. The record in Genesis 7:11 can be taken literally when it states that all the fountains of the great deep burst on the same day. A tension crack in granite will travel at nearly 3 miles per second. In this case, the crack propagated at this speed in 2 directions. The starting point of the crack appears to have occurred near what is now the Arctic Circle, somewhere in the East Siberian Sea. As stated before, the mid-ocean ridge is a scar on the ocean floor that roughly traces a great circle path of the crack that opened up in the granite shell above. As you are looking at this map, remember that hydroplate theory proposes that the continents as we know them today have slid to their current locations and thus have covered some sections of the mid-ocean ridge. This explains why the North American Rocky Mountain chain is bolstered by multiple adjacent chains and so appears much thicker than the narrow chain of South America's Andes. Notice that the mid-ocean ridge bisects itself at right angles in the Indian Ocean. This marks the point where one end of the crack intersected the other, which had already passed by. Since the two ends of the crack traveled at about the same speed, we can measure back equal distances to find the approximate initiation point. Now superimposing the original crust above the map, we can clearly see the mid-ocean ridge bisects itself by running the animation forward in time. The end that raced from the Indian and Pacific Ocean side reached the T first. Therefore, the other end coming around the African side abruptly stopped at that location. Note that this is much easier to see using a spherical globe rather than the distortions that come from a flat map. You can experiment for yourself with Google Earth's path tool by tracing the continuous path starting with the T in the Indian Ocean along the mid-oceanic ridge until you loop back to the T. Google Earth will tell you how long the path is, so simply divide the distance by 2 and then right-click on the path you just made and select the Show Elevation Profile option. A graph will pop up and then simply move the elevation bar to the halfway distance that you just calculated. An arrow will trace the path and show the spot on the globe. See what initiation point you get. Next time you hear the dogma that the mid-ocean ridge is a result of seafloor spreading, notice that usually only the Atlantic or Pacific ridges are given as examples. Now ask yourself how the typical seafloor spreading scenario fits over the mid-ocean ridge in the Indian Ocean. How is the material moving away in 4 directions, and perpendicular to itself? How do the forces produce spreading here and not also produce spreading up here? Why does the spreading suddenly stop at the crossing ridge and not continue through? If material is moving in these two directions, why are there no signs of compression or trenches in this area? Or does hydroplate theory offer a more reasonable explanation for this feature as we just saw? You may wonder why the crack did not stop moving once the water pressure was first relieved. It is because the subterranean waters were all connected and therefore at basically the same pressure. The speed of sound in granite is much faster than in water, and pressure waves in any material can only travel at the material's speed of sound. So the granite crack always raced far ahead of the water's pressure drop. Imagine you are looking at a cross-section of the granite where the crack passes by. Now we will pictorially see why the crack did not stop moving once the pressure was first relieved. Again, the subterranean waters were all connected and at the same pressure. The speed of sound in water is only about 1/3 the speed of sound in granite. So the leading edge of the crack always raced along the surface far ahead of the water's pressure drop. So you'd see the granite separate long before you felt the drop in the water's pressure. We speak of a crack initiating, but because the continents were so large and had been stretched over thousands of miles, there was a great deal of elastic strain in the plates. This thinned the plates slightly, just like a rubber band will thin as it stretches. And like a stretched rubber band, the granite stored strain energy like a spring waiting to snap. So once the crack sped through the granite, the tension in the plate was relieved, so the plate snapped back like a rubber band, breaking and quickly producing a gap a few miles wide. Then the high-pressure supercritical water jetted violently out of the rupture. Again, Genesis 7:11 records the events of that day. In the 600th year of Noah's life, on the second month, on the 17th day of the month, on the same day, all the fountains of the great deep burst open, and the floodgates of the sky were opened. This is the first time in the Bible that any event is recorded so precisely down to the day. They obviously witnessed something much more than a heavy rainstorm. Very literal fountains of the deep shot up, accelerating high above the atmosphere at hypersonic speeds. Some scoff at the idea that water could be ejected so high. However, high-speed vapor plumes have been observed presently on the moons of Enceladus and Europa. These examples give a glimpse of the much more powerful forces that Earth would have produced. The blue arrows represent the pressure of the waters of the great deep due to the weight of the granite above. For every action there is a reaction, so for equilibrium or no movement, the force of the blue arrows must equal the force of the red arrows, which represent the reaction force of the mantle pushing back. As we progress, pay attention to the blue and red arrows. The pressure of the water near the crack would drop. Since the pressure in the middle of the granite plate would be very high, while the pressure at the crack would be very low, this would cause the edges of the unsupported granite to bend down, creating a tapered nozzle at the crack. Remember, most of the weight of the granite was carried by the pressurized waters. As the subterranean water was escaping, pillars had to carry a greater load because the subterranean water pressure was dropping and therefore carried less of a load. Eventually, the pillars, which were brittle and porous from centuries of contact with supercritical water, failed from the added weight and began to crush and break up into fragments, causing enormous earthquakes within the plate. Every time a hydroplate oscillated down, it partially closed the nozzle-shaped edge of the plate. An entire ocean of escaping water was then forced to slow down, producing what is known as a water hammer. Water hammers can cause pressure spikes many times the initial pressure in a flowing fluid. Every time this happened, velocities at the crack would have spiked as well. Whenever a liquid or gas flows over a flexible surface, the flow can induce flutter in the surface. This is easily seen in a flag that is flapping in a strong wind. Hydroplate theory poses that during the beginning stages of the flood, as supercritical water rocketed out from under the plates, the flow of fluid under the plates, in combination with seismic waves from the buckling and crushing of these pillars, induced flutter oscillations in the granite plates which lasted for several weeks. Return oscillations lifted the fractured pillars from their bases, and then slammed them back down into the mantle, producing more vibration and fragments which were swept into the flow. As the edges of the plates oscillated down, flow was restricted while internal pressures spiked. As the plate edge oscillated back open, the tremendous pressure was released, so the fountains pulsed in tune with the plate flutter. It is hard to imagine granite 60 miles thick bending, but consider that the area of the plates was thousands of square miles across, so on a continental scale the plate thickness was tiny. Remember that many of the views you'll see here are out of scale so that we can see the concepts. For example, a more scaled view across the North American continent before it was compressed and thickened would look like this if the granite was 60 miles thick. When you consider that a plate was mostly suspended by a fluid foundation, it is not difficult to imagine bending and flutter in the rock crust. At the point of the crack, pressure dropped from 372,000 psi, or higher due to water hammers, to near atmospheric conditions. Similar to the phase change of a propellant like gunpowder, water changes phase and expands to a gas, increasing volume by 1,600 times. The phase change of supercritical water to gas was similar, but much more energy was involved. Because of this, the volume of expansion was much greater. Remember, the supercritical water contained tremendous stored energy, so while the pressure drop caused some expansion, it also began a chain reaction which released all its stored energy. The sudden pressure drop caused ion collisions, was added heat to the fluid, and because supercritical water's microscopic droplets had almost infinite surface area to evaporate, the added heat almost instantly converted to kinetic energy as the water expanded from the base of the crack. This chain reaction continued to occur all along the flow, which accelerated the fluid from the base of the crack to far above the atmosphere. With no atmosphere to produce drag, tremendous velocities were possible. Finally, in the initial stages of the flood, the waters of the Great Deep were subject to heat from nuclear reactions that appear to have occurred in the granite as it flexed and fluttered above the flow. In objection to Walt's estimates of temperatures of the supercritical water under the crust and the energy estimates involved, some apply simplistic heat transfer equations to the volume and mass of the atmosphere, and then declare catastrophic boiling or vaporization of all life. Others also argue that the hypersonic speeds of the fountains would have pulled the atmosphere up along with it and stripped it from Earth's surface. So is there a heat problem with this theory? If all this energy was released during the flood, would Noah roast? Well, I'd say not likely. Just because high temperatures and huge amounts of energy are involved does not mean everything nearby would be dead. Sometimes a picture gets this point across better than a technical discussion. That flame is probably about 1800 to 2000 degrees Fahrenheit. My hands are less than an inch away and could easily have stayed at that position till the bottle ran out of propane. So first consider that this is a scenario that involves directed energy. Yes, there was tremendous energy involved, but where was it headed? I think some of the confusion arises by immediately simplifying the problem and not accounting for everything happening throughout the entire scenario presented by hydroplate theory. Consider that when a fluid expands, it cools greatly. So by the time the initially high energy water directed far above the atmosphere fell back as heavy rain, any remaining heat would radiate into space, which is a huge, almost infinite heat sink. Remember the picture of my hands just an inch or so beside the torch. Air is actually an insulator, a very poor conductor of heat, especially when it is stagnant. Nearly all forms of insulation, from fur to your coat to your house walls, rely on still air to be effective at preventing conduction of heat. The great speeds of the fountain's flow mean that there will be little time for heat transfer with the atmosphere as it raced past. Like my hands, Noah was located beside and away from the fountains, and the air in between would have protected from extreme temperatures. Consider too that the atmosphere is like a wide, thick blanket for Earth, and it has tremendous inertia that would have to be overcome for it to be stripped away from Earth's gravitational pull. A focused high-speed flow is just about the worst method I can think of for imparting kinetic energy to a gas. If you question this, try an experiment. On a still, non-windy day, light a leftover 4th of July smoke bomb, then use a hose with its nozzle set to its most pinpoint setting to try to move the smoke around or out of your yard. After you get frustrated, try a slow-moving fan and then consider just how effectively a pinpoint high-speed flow moves a gas. It is a terrible method for moving a gas. Finally, consider that at the top of Earth's atmosphere, temperatures plummet to negative 150 degrees Fahrenheit and lower. So any air beside the fountains that was heated and pulled up with the flow would have a tendency to lose speed, fall away, and radiate any gained heat long before it floated back down. If interested in how this nuclear heating occurred, follow the link shown here to a presentation on the origin of Earth's radioactivity. There you'll find not only the explanation for nuclear heating, but also discovered the surprising evidence of plate flutter, how chondrules formed in meteorites, how heavy elements were produced during the flood, and how accelerated radioactive decay occurred, which produced the parent-daughter ratios which so many mistakenly think is proof for billions of years of time. For now, we will skip this subject as it would greatly sidetrack our review of hydroplate theory. Just realize that this nuclear heat produced within the plates greatly pressurized the supercritical water that had eaten into and was now partially constrained within the porous regions of the plates. Because the upper half of the plates were still solid undissolved granite, this pressurized water could only expand laterally and down through the porous channels. The expansion of supercritical water within the openings quickly fractured the lower regions of the plates. These dislodged porous fragments quickly fell into the pulverizing flow and were accelerated up into space. This process quickly eroded and thinned much of the originally thick plates. This would explain why the estimated 60-mile thick plates were eroded to today's average of about 30 miles thick. The flow under the plates produced extreme velocities high enough to launch materials beyond Earth's gravitational pull. These objects are observed in our solar system today as interstellar dust, comets, asteroids, meteors, and trans-Neptunian objects. Let's discuss some common traits these stellar objects share with Earth. Comets are about 38% water ice. Asteroids are loose collections of smaller rocks loosely held together by water ice. Both contain salt and silicates, which make up about 95% of Earth's crust. They also contain crystalline silicates, which require uniform temperatures of above 1300 degrees Fahrenheit and slow cooling under pressure to grow. How could this happen in space if space is the origin of these objects? Space is an environment of no pressure and near absolute zero conditions. Limestone and clays are found which require a body of liquid water to form. In 2011, the mineral cubonite was reported in Comet Wild 2. Cubonite only forms in scalding hot water between 122 and 392 degrees Fahrenheit, but comets do not reach these temperatures even at their cores. Comets, asteroids, and meteors contain olivine, which is a common mineral of Earth's crust and mantle. Olivine is also concentrated with iron-nickel in some meteors. Iron-nickel alloys found in meteors contain the unique Widmanstätten pattern, which again means the material formed under uniform temperatures of at least 1300 degrees Fahrenheit. The conditions in the Great Deep easily explain these surprising findings. Finally, and most perplexing, organic compounds, complex molecules, and materials like amino acid and even bacteria are found in these objects. Studies of interstellar dust scattered throughout the inner solar system near Earth's orbital plane find this, quote, dust actually matches the spectral properties of complex structures like frozen bacteria and cellulose. This has led some scientists involved to wonder if these materials somehow seeded and began life on Earth. Considering that their origin hasn't been explained in the ideal environment of Earth, it is baffling to think how these could ever form in the unfriendly conditions of space. For example, what protected these delicate structures for millions of years while fully exposed to harsh solar rays? Traditional explanations for these complex organic molecules are severely lacking. Of course, without question, the Earth's surface has the highest known concentrations of these familiar products of life. Where else does something like cellulose form and thrive? Often these bodies are explained as leftover building blocks of our Earth. So while there is much speculation over the origin of these objects and their content of trace organics, the evidence strongly suggests that we are standing on the source. Although rather large, asteroids like comets have low density and are weakly held together. Vesta is one of the largest and is almost big enough for its gravity to make it spherical. Ceres is the largest asteroid and makes up 1/3 of the mass of all asteroids combined. It has just enough mass to pull itself into a roughly spherical shape. The mass of all known asteroids combined make up only a small percentage of Earth's mass. So asteroids are probably not the fragments of a planet that completely exploded, as some people initially thought. Since asteroids are actually made up of many smaller rocks, dust, and water ice, it is not so hard to imagine them being ejected from Earth via mechanisms we just covered. As these particles traveled farther from Earth, their gravitational sphere of influence increased, so larger rocks gravitationally attracted more and more smaller rocks into their vicinity, which caused their gravitational spheres of influence to grow even more. Eventually, these mergings became comets and asteroids. Those that did not merge to become comets and asteroids are today's meteoroids. Some asteroids became so large that they maintained their gaseous atmospheres for much longer, which allowed them to sail on the solar wind past Neptune's orbit, becoming trans-Neptunian objects or TNOs. TNOs share many characteristics with asteroids. Both measure exceptionally low densities of around 2 grams per cubic centimeter. Both are often reddish in color due to the surface rocks containing iron oxide, oxides which likely formed due to the presence of water launched with the rocks in the fountains of the deep. When the mass of all TNOs is considered, then the percentage of the material ejected from the flood jumps to around 3% of Earth's mass. This line of evidence is one of the main reasons for changing hydroplate theory's estimated initial crust thickness to 60 miles. I say special conditions are required to form these objects because the gravity of small objects is tiny. Asteroids and comets would never accrete if the trajectories of objects and the angles of impact were random. Even landing a small, carefully guided space probe on a large asteroid or comet is incredibly challenging due to how low the gravity environment is. If traveling at even slightly differing speeds, impacts in space result in further fragmentation and breakup of particles, which will never return to each other. Just so conditions are required for accretion. All of these special conditions are accounted for and explained by the hydroplate theory. Items must be traveling at the same relative speeds and along the same trajectory. The presence of gases during this process greatly aids in aerobraking the inbound components, providing the best possible conditions for successful accretion. Many asteroids surprisingly have moons like Ida and its moon Dactyl. Capturing a moon is incredibly difficult for the same reasons we just discussed. However, moons would be expected if asteroids originated from a stream of particles with shared velocities and direction. Many TNOs have moons as well, as hydroplate theory would expect. Some TNOs even orbit each other at great distances. Another scenario which requires the unique conditions that only hydroplate theory seems to be able to provide. Some large asteroids have gently connected with their moon, like Itokawa. As stated, it is difficult to do this even with small, precisely controlled spacecraft. When the large size of these fragile bodies is considered, it is hard to imagine how this occurred randomly in space with no gaseous atmosphere to provide aerobraking. Notice that this picture of the surface matches what hydroplate theory predicts. Asteroids are not angular shards of a broken larger planetoid. They are low-density flying rock piles loosely held together by water ice. The rocks are well rounded. In this picture, some rounded boulders are over 150 feet in diameter. High-velocity flow produced many rounded objects discovered on Itokawa. Hydroplate theory readily explains these findings. Meanwhile, researchers like Donald Yeomans from NASA Jet Propulsion Laboratory realize the problem and currently seem stumped by what is observed due to their evolutionary viewpoint. Recent detailed explanations show comets have similar makeup as asteroids. In fact, some asteroids are categorized as both an asteroid and a comet since they sometimes vent gases and dust producing familiar tails. Comet nuclei like the one shown are low-density dirty snowballs composed primarily of water ice, dust, organics, and curiously again, rounded boulders. The surface of Comet 67P has layer upon layer of large rounded boulders at least 10 feet in diameter. This would not be expected if these fragments were due to collisions in space. They should be jagged and angular. Of course, rounded boulders is exactly what is expected if these fragments were once exposed to and tumbled in an extremely high velocity flow as they were ejected from the fountains of the deep. This is the same mechanism by which river rocks are rounded, albeit these large, quote, dino eggs were rounded much faster. Here's a close-up of a crater where hundreds of these rounded 10-foot boulders are exposed. Here again, rounded boulders are observed on the peanut-shaped comet Hartley 2. Like the subject of the origin of Earth's radioactivity, the hydroplate theory's full explanation of the origin of comets, asteroids, meteors, and TNOs would take us on a long bunny trail that would distract from this overview, so we will have to leave this subject and move on. A more thorough, in-depth presentation of this subject may be found by clicking on the following link displayed. To continue with the hydroplate theory overview, please click the following link to the next segment. In this next segment, we will move from discussing how some materials escaped Earth and come back to the escaping floodwaters of the Great Deep. Any theory of Earth's geology must explain the sedimentary layers found on the continents and on the ocean floors. What produced them? What was the mechanism? Uniformitarians say billions of years of weather, wind, erosion, coral formation, and ocean evaporation produced these sediments. Hydroplate theory's explanation of sediments is found in the materials of granite and the mantle floor that made up the subterranean chamber. The mechanism was the escaping high-pressure supercritical water, which easily ground and eroded the surfaces of the granite and mantle. So the fountains of the deep were full of tiny particles ground from these two surfaces. In addition to this grinding action, it is important to remember that the granite walls of the widening rupture were extremely unstable, since any rock below 5 miles was now unsupported and therefore was crushed, crumbled, pulverized, and ejected by the high-velocity upward flow. Of course, this was happening on both sides of the widening gap. This gap rapidly grew, putting great distance between the now separate sections of the plates, which would eventually become the continents. As the lower structural support washed out, suddenly the upper rock had no support, so it sheared and slid down into the flow with the same pulverizing results. So this accounts for the erosion and particles, but what about the cementing agents? Remember that for centuries, the supercritical water had dissolved minerals from the walls of the chamber, precipitating a mushy blanket of minerals onto the chamber floor in a process called outsalting. So the escaping water swept up this loose mix of minerals, including limestone, silica, salt, dolomite, and other ores. At the surface, these minerals became the cementing agents that locked sedimentary particles together, forming the sedimentary rocks we know today. Once the eroded sediments and watery slurry of minerals was deposited in thick layers on the surface, the mixture was at low pressure, and as the temperature cooled, over time, after the flood, the minerals in the waters precipitated out of solution and readily locked the crystalline rock grains together, forming sedimentary rock. This is the only explanation which provides adequate reason for why such thick, vast layers spanning continents are found to be so consistent and remarkably pure throughout. All gradual processes involving millions of years fail to explain the thickness, purity, and consistency of these layers over vast expanses. So we've just explained how sedimentary rock was ground and cemented and why the layers are so pure. But what caused the vertical layers to form all at once? And why are they neatly stacked on top of each other with sharp, undisturbed boundaries and no signs of erosion? Biologic evolution heavily relies on the geologic column as evidence to justify the theory that life evolved over eons of assumed time. But if thick layers do represent vast ages of time, why are they not eroded due to exposure to weather? Is there a better explanation for how these layers formed? Are there other mechanisms that explain these layers? Geologists often scoff at a global flood, claiming there should be a layer in the geologic column containing all forms of flora and fauna if it were true. Since there is no such layer, they conclude a global flood is merely a myth. However, they fail to comprehend the true power and forces described in the Genesis account. Few understand the sorting capability of liquefaction. As we'll soon see, many overlook that the entire geologic column is the layer that they are looking for as evidence for the flood. So the no geologic evidence argument appears to be a case of missing the forest for the trees. Anytime objects fall through a liquid or liquid is forced up through objects, liquefaction can occur. The natural result of liquefaction is that it sorts materials according to size and shape. Assume all these objects were the same density. Their shape and size alone would cause them to come to rest in layers as a function of how fluids flow over their unique surfaces. If these same size and shape particles had different densities, however, they could sort much differently without respect to size or shape. Different combinations of these properties for each particle will give different layering sequences. Sharp, even layers can form as particles are sorted by the liquefaction process. As loose sediment particles were laid down in mineral-rich waters during the flood, liquefaction occurred on a global scale in several ways. First, sediments falling through floodwaters experienced initial sorting as we just discussed. In addition, the tidal pull of the moon was unimpeded during the flood, with no continental slopes to crash into, so tides rose and fell up to 200 feet twice a day. High tide forced water down into these loose sediments. Low tide allowed the water within the sediments to rise up through them, while again causing liquefaction and further sorting. Then, as high tide came, the sediments were again pushed back down as the water was forced through them. Realize too that heavy rain and sediments were continuously deposited over time. So as initially sorted layers were buried and protected, the tidal liquefaction process began again on the newly deposited sediments above. This time variable and the phenomena of lensing prevented absolute perfect sorting of the geologic layers by size and shape and density. Rather, patterns of sedimentation tended to repeat. Probably the biggest driver of liquefaction was occurring from forces below the layers as well. The up and down motion or flutter of the granite plates produced extreme wave heights and much liquefaction. Today, liquefaction is observed when only a portion of a continent moves slightly for just a few minutes during an earthquake. Now imagine the effect of an entire continent blanketed with loose watery sediments undulating for weeks. This movement arranged deep sediments more tightly, so the water in between again was forced up through the particles above. There was one other event during the flood which again produced mass liquefaction in the sediments. Hydroplate theory refers to this as the compression event. We'll cover this last liquefaction episode later when discussing the compression event. During liquefaction, another phenomena is observed that should be realized. As differing sediments were sorted at different times, fine layers of clays and mats of uprooted vegetation were sorted within the layers and became trapped between layers of looser materials. As liquefaction cycles continued to occur, water from below ran into these fine, densely packed layers and retarded the flow up toward the surface. This produced pressure against the dense layer, which lifted all the layers above, producing water lenses within the layers. In this condition, water actually flowed uphill since pressures were lower upslope. Any low-density materials like vegetation or animal bodies were swept along these flows, producing coal seams, oil deposits, and many mixed fossil boneyards uncovered today. Just as particles were sorted by density, shape, and size, flora and fauna were also sorted. This is why so many of the same types of plants and animal fossils are found in the same layers worldwide. It is not evolution over time, it was the mechanism of liquefaction at work. This explains why some fossils are found in, quote, the wrong layers, and why polystrate fossils are found penetrating multiple layers that allegedly formed over millions of years. For one theory, these are expected results. For the other, they are a mystery and therefore must be ignored. In fact, you can see liquefaction and lensing for yourself by experiment. Get a couple of 2-liter plastic bottles and fix them to a teeter-totter arrangement. Fill one bottle halfway with any combination of mixed soil you wish and connect the hose between the bottles. Then add water to the other bottle and slowly tip them. After many back and forth cycles, layers and lensing will appear, until you have this. I saw water lensing between layers in this small scale setup as well. So the next time anyone says the evidence of a global flood does not exist, consider that perhaps the evidence is all around us, including the dead things, called fossils, beneath our feet. Obviously, fossils can only form if the animals or plants are rapidly buried and preserved in sediments. In addition to explaining the origin of sediments themselves, the grinding away of sediments from under the plates produced another feature shared by all continents. Naturally, most material was removed near the nozzle area, where the velocities were the greatest. The flow acted like a belt sander under the plates, causing a gradual thinning and tapering of the plate perimeters for hundreds of miles. At the same time, as flow and sediments rocketed out from the base of the crack, it expanded and somewhat uniformly beveled the edges of the plates. This tapering and beveling is seen on all continents today as continental shelves and slopes. As plates were eroded, the crack widened and continued to do so until it was a gap hundreds of miles wide. As this happened, the explosive launching power of the fountains decreased, so heavy, constant global rain soon ceased. According to Genesis, the continuous heavy Geshem rain stopped after 40 days. Geshem is Hebrew, describing heavy, violent rain. Hydroplate theory sees the heavy rain as having a cause-effect relationship with the fountains of the deep. Notice the initial cause described in Genesis 7:11 was the bursting of the fountains. Then heavy rains are mentioned. In verse 12, we see that the rain was continuous day and night for 40 days, so this was not like the rain we know today. Later in Genesis 8 verse 2, again the fountains are listed first as closing and then the rains were restrained. However, if the escaping waters were coming from under the hydroplates, The rising floodwaters would have blanketed the fountains and stopped the rain, but the weight of the plates would have continued to push the remaining water and thick sediments out and up to the surface. This understanding would explain why Genesis records that the waters continued to increase and prevail on the earth for 110 days after the heavy rain had stopped falling. Think of the simplified scenario of a sprinkler placed in an empty swimming pool. Rain is the immediate effect of the fountains, which are the causal source. Constant rain will continue for a time until the sprinkler orifice is opened more, or the depth of the rising waters overwhelms the flow from the sprinkler, or the pressure in the hose drops, or a combination of all three scenarios. However, until the valve feeding the sprinkler is completely shut off, the water levels continue to increase, even though there is no rain. So at some point early on in the flood, jetting water stops producing continuous rain, yet water and thick sediments continue to flow out from under the plates. Why the fountain stopped was simply because as water escaped there was less room for the plate to flutter, and it sank closer to the mantle floor. No flutter meant a halt to the electrical and nuclear energy being generated, which powered the fountains. Of course, this also prevented water hammers from causing pressure spikes. Notice what happened to the balance of forces as the heavy granite was eroded. With hundreds of miles of material removed from each plate edge, the imbalance grew. Only the strength of the mantle floor was keeping the red force arrows from moving. Eventually, the imbalance overcame the rock floor's low tensile strength. The rock mantle suddenly and catastrophically failed, buckling and producing deep tension cracks as it arched and rose up almost 60 miles seeking a new hydrostatic equilibrium. In the field of engineering structures, buckling is a dangerous failure mechanism because it occurs suddenly, with almost no warning, releasing much pent-up strain energy very quickly. Let's examine two theories for the ridge's formation, plate tectonics and hydroplate theory. You decide which makes the most sense. Here we see the commonly taught concepts presented by the theory of plate tectonics. Plate tectonics proposes that the mid-ocean ridge is the result of seafloor spreading which causes plate movement, which is said to be driven by convection of the mantle. This spreading and convection concept are then used to explain the fit of the continents in the past and why they have slowly spread apart. If plates are spreading at the mid-oceanic ridge, then they also must eventually run into other plates somewhere. It is alleged that major mountains and ocean trenches are the result of these slow plate collisions. These thick tectonic plates are said to be subducting or diving under adjacent plates and then deep into the mantle below. These examples are animated and repeated as dogma so many times that few question if these concepts are physically possible. Mantle convection is usually compared to boiling water or gravy in a pot. This comparison completely ignores seismic observation that the mantle is a solid, with viscosity many orders of magnitude above that of any liquid, making the convection mechanism in solid rock highly questionable, and certainly it has never been demonstrated. The enormous forces and mechanisms required to produce mantle convection are vaguely described and then assumed to exist. Most explanation of plate tectonics is littered with much speculation, yet there's little supporting data. The mid-oceanic ridge is said to be the point where the new ocean floor is pushed up to the surface by these convection currents. This is attributed to deep liquid magma coming up from the mantle, expanding and pushing the plates apart. At first glance, this may seem plausible, especially when narrowly focused at the mid-ocean ridge. Now, while it is true that magma expands as it rises near the surface, one must consider how magma acts in all conditions before concluding that this is an adequate spreading mechanism. Graphics like this depict the mantle as if it may be all liquid or viscoelastic like firm hot putty, giving the impression that it could actually circulate as the arrows indicate. The reality is that thousands of seismic measurements repeatedly give the same picture. The 1,800-mile thick mantle is a solid, with some faults and fractures in it, which produce some liquid magma at times. Understanding this picture makes those convecting arrows seem a much less convincing conveyor mechanism. Now let's consider that magma, which convection is supposedly bringing up to the surface to cause seafloor spreading. Repeated experiments show that magma is a compressible fluid. So when all properties of magma under all conditions are considered, a huge physics barrier arises for proponents of any form of plate tectonics. Because of its compressibility, magma changes density depending upon pressure, which is based on its depth in the mantle. As stated, magma produced near the surface will expand and exert pressure. However, at only a depth of 220 miles, the pressures on magma are great enough to compress it to a density greater than the surrounding material. This is called the material's crossover density. The point at which a fluid reaches this density is called the crossover depth. Rather than rising up, magma created below this level will sink. The even greater depth means more pressure, compression, and higher density, a runaway process that hopelessly dooms the magma of any chance of ever reaching the Earth's surface. It should now be increasingly clear that the magma thought to be the mechanism in support of convection theories is actually their downfall. Looking at the crossover depth at a global scale, we see the immensity of the problem for any form of mantle convection. Only a small percentage of magma in the mantle will ever rise, while the vast majority of liquid magma generated in the mantle will compress to a density higher than the surrounding solid and will tend to drain into the Earth's liquid outer core, which is twice as dense as the solid mantle. Ideas that plumes of magma could ever rise from this dense core should be discarded. Convection of the mantle is not possible. In spite of this, magnetic reversals are often cited as irrefutable evidence for seafloor spreading theories. It is claimed that the crust contains a record of old versus new crust, spreading since magnetic, quote, reversals are seen in the ocean floor. These zones in the crust are where magnetic material supposedly shows that the Earth has reversed its magnetic poles many times in the past. So the floor is like a historical tape recorder of magnetic variations in time. This became popular when magnetic fluctuations were measured on research ships sailing over the ridge. Measurements showed high and low spots. A line was drawn through the data. Data above the line was said to be normal, indicating times of magnetic north. Data below the line was labeled a, quote, reversal, indicating time of magnetic south. Remember, hydroplate theory poses that the mantle suddenly bulged upward when the rupture widened by hundreds of miles. This produced deep tension cracks in the surface as it arched and stretched. Hydroplate theory offers a more plausible explanation of this magnetic data. There are no magnetic reversals, just fluctuations in magnetic intensity over the ridge. Magnetic materials, magnetite and hematite and basalt, lose their magnetism when temperature is above about 587 degrees Celsius. This is called the Curie point. Although not molten, the mantle's heat increases with depth. The deep tension cracks allow seawater to circulate and therefore cool more magnetic material per unit area near a crack. So areas near the deep cracks are more magnetic, while areas far from deep cracks are hotter and less magnetic. The result is magnetic fluctuations as one passes over the ridge's many deep tension cracks. Rarely presented is the fact that these same fluctuations are also measured as one moves parallel with the ridge. Remember, the ridge's cracks run both north-south and east-west. If you cut through the view of the ridge along this dotted line, we'd see this. The same magnetic fluctuations are measured. Why is mantle convection in this direction never proposed? So again, we see that when all the data is considered, seafloor spreading theory lacks consistent explanation, while hydroplate theory provides a straightforward and consistent explanation of what is observed that matches all of the data. The mid-oceanic ridge has unique repeated topography. It has a unique system of deep cracks. The largest and longest cracks always run perpendicular to the ridgeline. These are called fracture zones, which dominate the pattern. The crest of each section of the ridge is always bisected by a wide, deep crack that always runs parallel with the ridgeline, called an axial rift. Large axial rifts are flanked on either side by many adjacent small cracks called flank rifts. Rifts stop at fracture zones because the stress concentration at the tip of the propagating crack cannot pass through the rock that is not highly stretched. Notice how often rifts in one section of the ridge do not align with rifts in the next section of the ridge. Seafloor spreading proponents attempt to explain these features with a complex series of movements and shifts. All this shifting of sections back and forth is alleged to be occurring at the same time the seafloor is spreading away from the ridge in two directions. Hydroplate theory maintains that all these are simply deep tension cracks, and their unusual pattern is merely a record of a unique failure mechanism of the material, which explains why the cracks are perpendicular and why fracture zones always dominate. When in bending, plates develop cracks that form parallel with the bending axis. As is commonly done when teaching material mechanics, I've illustrated this using foam to exaggerate the deflection and to aid in visualizing these concepts. I sliced the same piece of foam in two perpendicular directions. The two pictures are of the same piece of foam. As you can see, when bending occurs along a single axis, only one group of simulated cracks opens up in the foam. To get the tension cracks to open in two directions, the plate must experience bending in two axes. Here again is the same foam sample bent over an exercise ball, so when the spherical mantle foundation was exposed and sprang up, it buckled and stretched in two directions, which resulted in two perpendicular series of cracks forming almost simultaneously. I say almost simultaneously because the timing of the crack formation is the reason that the fracture zone cracks dominate, and why rift cracks cannot cross fracture zones. Fracture zones are not due to complex shifting of faults. They simply had a head start on the rift cracks as erosion of the granite plates progressed above. We've been following the balance of the blue versus the red force arrows in 2 dimensions. But consider what was happening in the 3rd dimension along the ridgeline. While there were a few unsupported forces perpendicular to the open crack, there were many more unsupported forces along the length of the crack. So well before the mantle ever arched up across the exposed crack, it first arched down the crack along the green arc. As this occurred, the mantle stretched and cracked in tension. These initial tension cracks always formed and grew first, and are what we see today as fracture zones. As the granite plates slid away from the rising bending mantle floor, axial rift cracks began to form along the ridge as it finally buckled, stretched, and failed in that direction. As the plates rapidly slid away, the rising ridge of the fracture zone cracks raced ahead and deepened. The mantle continued to stretch and new cracks formed along the ridge that were adjacent to the axial rifts. As axial and flank rifts ran into the deep fracture zone cracks that had already formed, they could not jump across the already deep and wide fractures. Precise measurements of the ocean's surface affirm hydroplate theory's idea that fracture zones are actually deep open tension cracks rather than shear planes along shifting faults. Sea level is not actually level because Earth's gravity is not the same in all locations. Large massive objects like island chains or the mid-oceanic ridge gravitationally pull the surrounding water up toward them. For example, the Hawaiian Islands raise the adjacent ocean levels 80 feet higher than they would be if those islands weren't there. Conversely, areas of the ocean floor that are missing mass, like trenches or deep, wide open tension cracks, will have a lower sea level than the denser surroundings. Because of this effect, fracture zones show up as areas where sea level is below normal. If fracture zones are just shearing faults rubbing against each other, then the sea level should be relatively level across the fault line because the mass, shown as M's in the picture, are uniformly distributed across the surface. However, areas along fracture zones register as areas of low sea level, meaning there is missing mass over the deep open cracks. Only a deep open crack explains this. You decide. Many times, chapters of Psalms have a double meaning where events described from the psalmist's experience are also describing events of the past or future. Psalms 18 it was written by David about his deliverance from Saul. But David's description of torrents, storms, dark rain, clouds, hail, thunder, lightning, and being drawn from the deep water bear a striking resemblance to experiences that Noah would have had. If this chapter has a double meaning related to the flood, then Psalm 18:15 seems to be describing something very similar to the hydroplate theory's rendition of how the mantle foundation of the earth was exposed and laid bare as the granite plates slid away from the rising mid-oceanic ridge. As will soon be explained in detail, the mid-oceanic ridge appears to have first buckled up in what is now the Atlantic Ocean. This uplift in the Atlantic caused the plates to slide downhill. This was only possible because the plates were well lubricated from below by remaining trapped water of the deep. thus the theory's name hydroplate. As these continental plates rapidly slid away, the compressed Atlantic floor continued to spring up roughly 60 miles until it again reached hydrostatic equilibrium. As this continued, the plates picked up speed, and because of their great mass, they gained tremendous kinetic energy. This rapid continental drift was not only due to the rising Atlantic mantle, it was aided by another process occurring deep within the Earth at the same time. As the mantle buckled and rose up, it did not open up a void because pressures at such depths are too great for any void to actually open. This condition means that the material could only move by shearing, which produced friction and heat like when you rub your hands together back and forth. As shearing continued at greater depths and pressures, the tremendous heat generated melted the shearing walls even if they only moved a few millimeters. As the chamber floor rose to become the Atlantic floor, mantle rock below that floor had to rise as well, thus the Pacific side of the Earth sank. Once melting occurred along one of these deep vertical faults, a point of no return was crossed because, as we've already discussed, magma generated at these pressures below the crossover depth is so compressible that its density increases, causing it to sink. The more it sank, the greater its pressure and density becomes. Eventually, the magma ends up in the Earth's core, where its density is about twice that of the compressed solid rock inches above the core. Therefore, for every 2 units of mantle volume that drained into the core, only 1 unit of volume was added to the core. While the Atlantic edge of the plates were pushed up by the mantle as it moved toward hydrostatic equilibrium, rock on the opposite, or Pacific side of the Earth, was rapidly pulled down as the deep mantle melted and contracted by 50%. This tipped the plates to an even steeper incline and produced tremendous suction. Within hours, shearing occurred around what is now the Pacific Ocean, specifically along a horseshoe-shaped path called the Ring of Fire. This explains why the Ring of Fire is the most volcanically and seismically active region on Earth. For the floating continental plates, these two forces, both powered by gravity, simultaneously caused a rapid drift away from the bulging Atlantic floor. Because the plates were lubricated by water, they easily slid and rapidly gained speed and momentum. Later we'll cover, in much more detail, exactly how the center of the Earth melted, which resulted in subsidence and burial of the Pacific plate. But for now, we will continue to follow the chain of events occurring on the rapidly sliding American, Eurasian, and African plates. This rapid sliding of plates resulted in the formation of the Atlantic Ocean Basin, and explains why the Atlantic shorelines of the Americas and the Euro-African continents fit so snugly against the base of the mid-Atlantic ridge. Eventually, the rapidly sliding plates either ran out of lubricating water and ground into the mantle or hit obstacles like the mid-oceanic ridge in the Pacific. Hydroplate theory labels this the compression event, which occurred in approximately 1 day as the plates crashed to a halt. Friction from the fast-moving plates sliding on rock at high pressures melted the surfaces. Because granite is composed of differing minerals with differing melt points, most of the magma produced was from quartz, which has the lowest melting point of granite's 4 base minerals. Water still trapped under the plates and in the sliding porous surfaces dissolved into the accumulating magma, which dropped the magma's melting point even further. As the plates decelerated, the tremendous momentum fractured and thickened the material as it compressed. As the material buckled, fractured, and thickened, the forming continental surface rose high up out of the floodwaters. Rising mountain chains and thickening plates lifted and trapped large inland seas on top of the continents. Much of this water remained trapped for centuries. So after the flood, much of the continent's shelves were above sea level. For several generations, animals and people were relatively free to move from continent to continent. As the plate material was rapidly crushed, most cracks were quickly filled with extremely high-pressure quartz magma injected into them from below. Coal and oil deposits are viewed as the product of millions of years by evolution. However, multiple lab experiments show that these materials can be rapidly produced via extreme heat and pressure. Likewise, metamorphic rocks like marble and diamond form quickly under similar extremes. Carbon-14's rapid decay rate should yield extremely low, almost non-existent levels in these deposits if they're millions of years old. However, the consistent measurement of large concentrations of carbon-14 in coal, oil, and even diamonds is a glaring contradiction to the millions of years concept. This is rarely discussed. Hydroplate theory's concept of a recent compression event as a result of the Genesis flood provides the work required to generate the extreme one-time conditions that produced and concentrated these organic-based products rapidly. Of course, the high carbon-14 levels are expected if this all happened very recently, rather than a surprising anomaly for theories that promote an old Earth. This is all well and good to show in an animation, but what physical evidence is there for rapid deceleration and crushing of the continental plates? Areas like deep canyons with deep fractures reveal the top of the bedrock granite of continents. Here we see Colorado's Gunnison Canyon. These areas indeed show that the material has been rapidly crushed and injected, producing a spider web of quartz veins. Only rapid crushing combined with the lowered melting temperature of water dissolved in quartz would explain why both large and small cracks are filled with quartz. The dissolved water in the quartz kept the magma in a liquid state for longer, allowing it to fill both large and even small cracks before it solidified against the colder rock walls. The quartz-filled cracks of the Grand Canyon's deep inner gorge also reveals this evidence of rapid crushing. While the basement rocks show that the material was rapidly crushed, many sediment layers further show that this crushing and compression must have been due to a rapid and massive deceleration event. How were these sandstone layers tipped and beveled so evenly? This again points to a rapid one-time event. Similar evidence is seen on a large scale. The Grand Canyon's great unconformity of beveled layers speaks to the scale of this event. Layers below appear to have been cleanly sheared off with flat layers then stacked above. What forces or mechanisms could do this so evenly? Uniformitarian geology's label of unconformity betrays the lack of an explanation for this feature. We'll soon see beveled layers are actually strong evidence in support of hydroplate theory's compression event. Uniformitarian geologists note that fossils are only found in the horizontal layers above the beveled line. This has led to the belief that life suddenly began after these layers were beveled. This is termed the Cambrian explosion, where all animal and plant life suddenly appear at the base of the Cambrian layers. Rather than speculation, hydroplate theory will show the mechanism that explains why fossils are only found above the great unconformity. The crushing, compression, and deceleration of the compression event readily explains all these observations. If you'd have placed an indicator in the soft sediment layers produced by the flood before the compression event, it would have moved with the rapidly sliding plates and sediments. But as the plates crashed and began slowing, the indicator would have bent in a direction of the deceleration, showing that the force of deceleration was present and indicating its direction. As the deceleration occurred, resistances not only slowed the plate but compressed it, causing it to buckle up at certain points of weakness. This caused the soft, unhardened layers still filled with water to incline and deform with the buckling plate surface. As the plates decelerated and compressed, the sediment layers did too. Because they were still all water-filled and unhardened, the compression and repacking of particles once again produced massive liquefaction within the layers, as water was squeezed out and forced up. Because the layers were all now steeply angled rather than flat, any low-density items like flora and fauna were rapidly swept into and along reopened water lenses within the layers. This material was transported uphill as water powerfully flowed from high to low pressures. This explains why lower regions below the unconformity contain no fossilized remains. As layers were lifted up above the apex of buckled regions during the continued and increased deceleration, uncemented particles above were no longer supported by the solid crystalline rock below, and a shear plane quickly developed between supported and unsupported grains. These upper sediments were quickly infused with the waters flowing up from the liquefaction lenses of the tipped yet supported layers below. The flora and fauna from these lower layers were rapidly transported into the upper sediments. Eventually, the unsupported sediments, plants and animals, now infused with lubricating water, slid along the shear plane, which easily beveled the still soft layers below. As this occurred, liquefaction again sorted particles, forming new horizontal layers above. Notice how hydroplate theory is the only theory that provides detailed cause-to-effect reasoning and a physics-based description of forces and mechanisms explaining how these features formed. Conversely, those whose theories do not expect or can explain this continue to call this a great unconformity. At this point, you've already seen how entire mountain chains formed on the continents. Rather than millions of years, this occurred in hours. But let's discuss this further. Just as a thin sheet slid on a smooth surface buckles and deforms along the leading edge where it encounters resistance, so too the leading edges of the continents buckled and thickened the most along the leading plate edges, which were the first to encounter resistance. This explains why the dominant Andes and Rockies mountains formed on the leading western side of the plates and run parallel to the Atlantic mid-oceanic ridge. Likewise, the dominant mountain chains of Africa also run parallel to the Atlantic mid-oceanic ridge, but as expected are located on the eastern shore of the continent. Here is yet another example of evidence of rapid compression that must have occurred while all layers were still soft. Rock does not bend. This picture of finely compressed layers in the mountains of British Columbia is impossible to explain from an evolutionary perspective of individually deposited and hardened layers over millions of years. Material mechanics does not support this idea. Hard and brittle rock layers do not deform like this without cracking in hundreds of locations. All these layers must have been soft, having been deposited at the same time. Months later, while still unhardened, they were rapidly compressed like an accordion as the sliding North American plate decelerated to its current position. Later, limestone precipitated out of the water and the water drained out, cementing the deformed layers into hardened, brittle rock long after the deformation. This yet again supports the idea that the high mountains we know today formed quickly after the flood. Large plateaus are found adjacent to large mountain chains. The Colombian, Colorado, and Himalayan plateaus all lie next to thick, massive mountain ranges. Geologists like Professor George Kennedy recognize the puzzle presented when attempting to explain observation by physical means. He asks, what mechanism would cause a large volume of low-standing continents to rise rapidly a mile into the air? Furthermore, evidence from gravity surveys suggests that the rocks underlying the Colorado Plateau are in isostatic balance. That is, this large area is floating at its correct elevation in view of its mass and density. Recent seismic evidence confirms this in that the depth of the moho under the Colorado Plateau is approximately 10 kilometers greater than over most of continental North America. Kennedy concludes, we have then a double-ended mystery, for the Colorado Plateau seems to have grown downward at the same time that its emerged part has arisen upward. Here we see graphically what Kennedy found so peculiar. What forces caused the plateau's layers to rise up, while at the same time the density boundary of the Mohorovicic discontinuity was forced down? With a lens of millions of years, the forces involved are vague and mysterious. Terms like uplift may vaguely explain what obviously happened, but it completely fails to provide a mechanism that actually explains the results that we see. Hydroplate theory readily explains the forces and the mechanisms that lifted the plateaus. Let's explain. It was simply hydraulic lifting at work due to temporary imbalance of forces after the compression event. The causal force was again gravity. As newly formed massive and high mountains sank down, the relatively thin adjacent continental material was hydraulically lifted over time, creating a plateau. Large plateaus are always found adjacent to large mountain chains. The Colombian, Colorado, and Himalayan plateaus all lie next to thick, massive mountain ranges. Hydroplate theory uniquely explains the essential conditions that both raise the plateaus and cause the moho beneath to be depressed. But where did the liquid under these mountains come from? As we've seen, magma chambers are not the result of plumes rising against all odds from Earth's core. Rather, the magma was produced by the friction and heat generated as the buckled and thickened mountains sank into the mantle. Water then dissolved in the magma, reduced its melting point, and this is why volcanoes in these areas today release so much water during eruptions. These volumes of magma were generated mostly under buckling mountains, which in turn contacted more heavily with the mantle surface as they slid. Over the centuries following this event, the magma under the mountains was slowly injected under adjacent thinner layers of the plates. Again, notice the lack of mystery here. This all happened as a natural function of gravity acting on massive mountains as they slowly sank like giant pistons. The fluid beneath spread sideways under the thinner adjacent crust until enough pressure was generated to shear the material above. This shear line formed a somewhat vertical fault. The fault was injected with magma from below, which lubricated each new block and allowed it to rise even further until it locked up against the neighboring block. Once the block was either restrained or rose high enough, continued pressure from the sinking mountains began building pressure under the next segment of material. Once it failed in shear, it too was lifted, and this is how block faulted features like the Grand Staircase formed. It is also the mechanism that lifted plateaus to their current state. Since each block's mass and area was tiny compared to the mass and area of the nearby sinking mountains, the blocks were raised over a mile above their surroundings. Along some faults, pressurized magma reached the surface and spilled out on top of sedimentary layers. The hot liquid pooled at low points in the topography, and hardened and years later protected the sediments below from violent flows as huge inland lakes breached and scoured away soft sediments as they drained. In some areas, these became buttes like Red Butte in northern Arizona, which is capped with a thick layer of volcanic rock. The weight of the injected magma combined with the weight of the lifted plateau and the simple driving mechanism of gravity further explains the second half of the plateau mystery. Naturally, the Moho boundary was pressed down by the extra weight of the magma under the plateau as it too settled back into hydrostatic equilibrium. Two more observations are also explained. Mountains were heaviest, so they settled more. The Moho is the deepest under the mountains. Conversely, the Moho is exceptionally shallow over ocean basins. As the continents settled down, the ocean floors had to rise in compensation for the downward flow of matter, just as the topography of a waterbed does when you lay on it. Finally, the hydraulic lifting of the plateaus is the key to understanding how the Grand Canyon actually formed on the Colorado Plateau. As the plateau was lifted, huge inland lakes were lifted as well. Here is a map of the Four Corners area of southwestern United States. Some people will say the Grand Canyon was carved during Noah's flood. That is not really correct. It should be seen that the flood began a series of events which after several centuries resulted in conditions which carved this unique canyon. Centuries after the flood, as the Rocky Mountains sank, the Colorado Plateau was hydraulically lifted. Two huge inland lakes, Grand Lake, discovered by Walt Brown, and Hopi Lake, were located on this forming plateau, and they were also lifted. Eventually, Grand Lake, with a volume of about that of Lake Michigan, breached a natural dam located at the funnel feature in this circle. It spilled out across the upper sediments, still soft and impregnated with floodwaters. Once the body of water began flowing, the low pressure caused all waters in the lake to flow toward that low pressure point. As happens with flowing fluids, a widening funnel-shaped channel was quickly carved and the lake spilled out over the sediments in northern Arizona. The eroded funnel scoured sediments until it reached the thick layer of hardened limestone today known as the Kaibab deposit. The erosion widened the channel to about 12 miles across and formed the Echo and Vermilion Cliffs, which overlook Marble Canyon. Because the material above was removed so quickly from the Kaibab, it buckled, arched up, and cracked in tension down the middle of the channel, producing narrow Marble Canyon, similar to what happened when the mid-oceanic ridge buckled up. Sediments were quickly washed away in sheet flow as water from the lake combined with water already in the sediments. These were the conditions which began what is referred to as the Great Denudation, where around 1,000 vertical feet of Mesozoic sediments were stripped off this region in northern Arizona. Remember how I said Red Butte near Williams, Arizona survived this scouring? Here is the most likely way all that volcanic rock ended up on top of it. At some points, magma from below the plates that pushed up the plateau traveled up along the sheared faults and burst out above the newly formed sediments. This naturally flowed to low spots in the sediment topography where it cooled and hardened. As Grand Lake breached, the torrent of waters eroded the soft sediments. As sediments were swept away, the thick, hardened layer of volcanic rock capped and protected the sediments underneath, forming a volcanic capped butte. As this massive sheet flow of sediments progressed, the flow eroded and undercut the western bank of Hopi Lake, which rested about 250 feet above Grand Lake in elevation. Hopi Lake soon breached and added to the catastrophic flow. There are many other strong evidences that corroborate this unique scenario that hydroplate theory presents. Like comets and asteroids, however, I will move on as this would greatly distract this overview. It should now be clear that the tiny Colorado River, which is a pretty normal river, even when it is not dammed up, could never have carved the Grand Canyon. Only the unique conditions explained by hydroplate theory fully account for how this land feature formed. Another series of phenomena spanning continents has been observed that when all data is considered seems inexplicable. However, we'll see hydroplate theory links these observations to the Genesis record of the flood. For centuries, unfossilized frozen mammoth and rhinoceros remains have been recovered from the tundra in northern Siberia, Alaska, and Canada. One such mammoth was recovered from Siberia's Beherovka River. The 50-year-old male was found in a freshly eroded bank 100 feet above the river in 1900. A year later, an expedition led by Dr. Otto F. Herz painstakingly excavated the frozen body and transported it to the Zoological Museum in St. Petersburg, Russia. Beherovka was upright, although his back was humped, and his hind legs were straight and rotated forward at the hips into an almost horizontal position. This strange, contorted position was further exaggerated by his raised and spread front legs, as if struggling to right himself. In the museum, Beherovka was reconstructed and displayed in the same body position as it was found. Several ribs, a shoulder blade, and the pelvis were broken. Amazingly, the long leg bone in its right foreleg was crushed into about a dozen pieces without noticeably damaging surrounding tissue. However, there had been considerable bleeding between the muscles and fatty connective tissues in this area. It is most likely that this leg was crushed after burial and not before. Here's why. First, it is doubtful that this severely damaged limb could have been used in the spread, struggling position it was found in, since the smashed bone would not have resisted contraction forces from the muscles, nor could it have supported any weight. Therefore, it seems the limb was fully functional and in use at the time of burial. Second, crushing of a mammoth leg bone without evidence of external tissue damage from a large impact while still showing bleeding in tissues near the crushed bone indicate rapid and deep burial soon after death. Falling into a deep, cold crevasse alone would only cause the bone to bend and snap in one place where it was the weakest. Think of pushing a wooden yardstick at the ends. It will bend and snap in one place. Beherovka's leg bone was crushed into a dozen or so pieces. This indicates the leg was encased and surrounding tissues were evenly compressed against and supported the bone so that it was not able to bend. Continued rapid burial from above vertically compressed the body and the surrounding layers as it was buried in. Since the bone, too, was being compressed but could not bend, crushing became the failure mechanism. The continued heavy burial above the mammoth's body must have happened during or soon after death for bleeding in local tissues to have occurred before they froze. Extremely good preservation indicates that the burial material must have been extremely cold as well. Other fossils were also buried around the site. Below his right forefoot was the end of a very hairy tail of a bovine animal, probably a bison. Also under the body were the right forefoot and left hindfoot of a reindeer. The whole landslide on the Beherovka's River was the richest imaginable storehouse of remains. In the surrounding loamy soil was an antelope skull and the perfectly preserved upper skull of a horse with fragments of muscular fiber still attached. Also tree trunks, tree fragments, and roots. This vegetation differed from the amazingly well-preserved plants in the mammoth's mouth and stomach. Many fossils are found in groups at high points in the land's topography. These are sometimes referred to as fossil graveyards. The fauna represented in these graveyards are diverse and sometimes they are prey and predator in close proximity. Being trapped in bogs are sometimes thought to explain the diversity, but bogs would be located at topographical low points. What would cause such diverse groups to gather in close proximity on hills? Raising water and/or sediments is most likely the explanation. The cause of Beherovka's death was determined to be suffocation because blood was found to be coagulated in its capillaries. Also, the male genitalia was found to be erect, which is a telltale sign of slow suffocation. Other mammoths recovered show similar signs of asphyxia and inhalation of dust and silts. Interestingly, the stomach contents were well preserved and showed little signs of breakdown by enzymes. This is unexpected. The mammoth's large thermal mass should have kept the stomach warm for a long time, even if Berezovka had died in the coldest Siberian winter storm. Since the body was rapidly buried, this is even more perplexing since burial should have protected from exposure to the cold. The plants found in the stomach and mouth were so well preserved that each species of fauna could easily be identified. It is almost as if the body was buried in something colder than dry ice. Some of the plants found were not native to Siberia today. The extreme preservation also told examiners when the plants were eaten. Inexplicably, this pointed to a late summer death when temperatures would have been warm. Every time a frozen mammoth's time of death can be determined, the estimates are of a late summer to early fall time frame. This is surprising if each death were random and speaks to the possibility that a large-scale event killed and preserved these bodies. A warm weather death flies in the face of traditional theories attempting to explain the preservation of frozen mammoths. What's more is that the recovery team reported the meat was not putrid or rotten, but fresh enough that their sled dogs ate some of it and did not get sick. Close examination of Berezovka's soft tissues showed the cell walls had not burst, as they would have at normal freezing temperature rates. For this to happen, the cell needs to freeze rapidly before breakdown produces water within the membrane, otherwise the water's expansion upon freezing tears the cell wall open. For this to happen, frozen food experts point out that a live animal of this size would have to be exposed to extreme cold of less than negative 150 degrees Fahrenheit in a blast freezer. The preserved stomach contents deep inside the warm carcass indicate external temperatures must have been below negative 175 degrees Fahrenheit. The puzzle of replicating the observations are almost unbelievable. Remember, the crushed leg bone indicated rapid burial soon after death, which normally would have insulated the still warm body. So Berezovka had to be buried in contact with at least some fill material that was at least 65 degrees colder than dry ice. But how could temperatures have dropped so rapidly during the summer? And even if we can imagine a freak cold snap, this does not explain what must have been sustained cold that could have kept the body from rotting all this time. Before tackling this challenging scenario, let's first cover some more info on just what type of environment the woolly mammoth appears to have lived in. Because they have long hair and are found in what is now the Arctic Circle, it is automatically assumed mammoths are Arctic animals. But the easiest and most accurate way to determine an extinct animal's or plant's environment is to identify familiar animals and plants buried nearby. For the mammoth, this includes rhinoceros, tigers, horses, antelope, bison, and temperate species of grasses. All live in warm climates. Some burrowing animals are found too, such as voles, which would not burrow into rock-hard permafrost. Even larvae of warble flies have been found in frozen mammoths' intestine, larvae identical to those found in tropical elephants today. No one argues that these smaller animals and plants buried near the mammoths were specially adapted to the Arctic, so why do so for mammoths? Most assume mammoths are adapted to the cold. However, studies of recovered DNA fragments show mammoths to be closely related to the Indian elephant. Many mammoths are found with heavy layers of fat, assumed to be for insulation. However, fat only comes from caloric intake. Fat is an indication of ample food supply that the Arctic does not provide. Arctic herbivores today have little fat. Another popular myth is that mammoths have woolly insulation. Actually, mammoth wool is just hair. Unlike actual wool, mammoth hairs have no overlapping scales to trap air. Besides, sheep have wool but do not live in the Arctic, and mammoth hair is not even insulating like fur. Mammoth skin has no erectile muscles or oil glands to produce the insulating properties found in fur. Some say the large tusks were used to move snow and ice to get to food. This is ridiculous. Some mammoths seem better fed than their modern cousins who are surrounded by food that they don't have to work for to expose. How could a mammoth work all day clearing snow in the cold just to eat and be fatter than a tropical elephant? Carrying heavy tusks around means more work, which requires more calories, and they'd have a lot of work to do just to stay healthy. Grown elephants average 300 pounds of food and 30 to 60 gallons of water per day, and they spend most of their waking hours eating it. Imagine shoveling snow all day with the equivalent of 2 sticks in the Arctic temperatures, eating frozen or nearly frozen food. I'd think I'd be exhausted, cold, and hungry. Considering this, the evidence clearly points to mammoths being temperate creatures living amongst other temperate fauna in a food-rich environment. The perceived cold weather adaptations are purely imagination. There are other evidences that the environment buried under the tundra experienced a rapid freeze. Second-hand reports describe the apparent near-instant freezing of a flowing river found buried in the frozen ground, with fish frozen in place. Rivers do not freeze instantly. Rather, they freeze from the top down. The ice insulates the remaining flowing water below and prevents complete freezing. A second report is even more surprising. 50 oxen were found trapped in a remote frozen river. They were found as if attempting to cross when the river instantly froze them in place. How could a river freeze so fast that a large, powerful animal could not exit in time? Other findings in the Arctic indicate rapid freezing of a once lush, temperate region. Barren Axel Heiberg Island and Ellesmere Islands are found to have once supported temperate animals and vegetation, which are now buried under the tundra. Note that some animals recovered are burrowing animals that could not dig into rock-hard permafrost. Others are cold-blooded. Large trees were also found. In fact, vast frozen, non-fossilized forests that once thrived in the now barren Arctic Circle continue to surface as summer runoff erodes and releases the timber from the frozen muck. Driftwood of large, non-native trees released from the seafloor still washes up on the shores of remote islands north of Siberia. Northward flowing rivers erode the muck below and see driftwood collect along their banks as it is carried out to sea. Because there are almost no trees growing now in these latitudes, natives use the driftwood as a source of fuel and building material. Oil drilling in northern Alaska commonly penetrates what is described as a flattened, unfossilized forest under hundreds of feet of frozen muck. There is a glaring problem with this. The frozen trees are not native to the Arctic. These tree species only grow in comparable forests thousands of miles further south. We might imagine a global climate being warmer in the past and that this would explain this thriving forest. But the problem is more than just the cold temperatures. These trees need a certain amount of sunlight just to live. These latitudes do not provide sunlight for these trees to ever grow, even if temperatures were right. There is a reason these trees show such barren landscapes. Trees do not do well here. The Antarctic also reveals similar evidence that the climate was what's warmer on it. Large deposits of coal and oil indicate large forests. Dinosaur fossils also indicate a warmer climate. Remember, these indications of rapid and permanent freezing of temperate to tropical flora and fauna are spread over 2 continents, and the type of flora recovered could never grow at the extreme latitudes they are now located. So simple climate change cannot completely account for what we observe. Therefore, any theory must explain how these plants grew and how they received the solar energy they require to grow as they did. Only hydroplate theory will fully explain what happened. We will now unwrap hydroplate theory's explanation of events by answering these questions that any theory must address. How did it get so cold so fast during late summer? If the poles were warm, what happened? How did plants get sunlight? How did it stay cold? The answer to the first question is cold hail. Extremely cold hail. During the early stages of the flood, as the fountains of the deep burst and shot water high above the atmosphere, some of the water, laden with sediments, soon froze as it radiated heat into supercold space. Above the atmosphere, temperatures are well below negative 150 degrees Fahrenheit, especially on the night side of Earth. These frozen droplets were supercooled well below normal freezing and were transformed into muddy hail which fell back down, blanketing vast areas in thick blankets of extremely cold hail. These warm climates were quickly transformed in hours. The dense sediments trapped in the hail caused it to sink to the bottom of any bodies of water. The heat from even flowing rivers was quickly absorbed by the supercold hail, and some rivers froze from the bottom up, trapping fish and even crossing herds whose feet were quickly frozen in place. Having originated from the supercritical water far below the surface, the water in the hail contained not only dissolved sediments and minerals, but also dissolved gases like carbon dioxide. Low points in topography soon became suffocating death traps for any air-breathing animals. Larger animals were able to move further through the freezing hail and toward safety of high ground before being overcome by either low oxygen levels in the air or exposure to the unrelenting cold of the hail. The hail's close contact with the bodies conducted heat extremely fast, freezing and encasing tissue soon after death. As the flood continued, muddy waters deposited more heavy sediments on top of the frozen layers, which compressed the bodies. So cold hail can explain the extreme cold, but what about the next summer and the years to follow? How did these remains stay frozen when the region appears to have been a warm, temperate to tropical zone? What about the last three questions? Hydroplate theory offers one simple answer for all three questions: the big roll. Earth spins around its axis, and we assume the continents have always spun in the same direction. However, as we've discussed, there is a problem with explaining how temperate plants and animals could survive, much less even thrive, at high latitudes relative to the sun's rays. Could Earth's surface have shifted? If so, how? Was the formerly temperate region originally further south and much closer to Earth's equator? If so, there should be other large-scale evidences of this alleged roll pattern that should line up with this idea. And as we'll soon discover, these evidences most certainly exist and line up as expected. Remember, according to hydroplate theory, before the flood, the mass on Earth's surface was somewhat evenly distributed. However, after the separation of the hydroplates followed by the compression event and the melting of the inner Earth, the Earth's surface mass became unevenly distributed. Newly created mountain chains from the compression event and contraction of the mantle set the freely spinning Earth temporarily out of equilibrium. The Himalayan mountains and the high Tibetan plateau became the highest, most concentrated area of mass on the Earth's surface. For any spinning object, each point of mass is acted upon by centrifugal force. If the mass of all points on the object's surface are even, then there is equilibrium and the surface spins stably relative to the spin axis. However, if you were to arrange mass unevenly on the surface, the area of concentration with the increased centrifugal force will drive that area toward the equator of the spinning object. Notice that even though the spinning object rolls relative to the equator, the object's axis of spin does not roll or tilt significantly at all. Since the Earth is spinning in frictionless space, this seemingly impossible scenario played out quite readily as the laws of angular momentum naturally pursued a new state of equilibrium after the compression event. Notice that depending upon where the mass concentration is located affects what parts of the surface rolled the furthest. Areas directly in line with the extra mass see the greatest roll from the equator, while areas adjacent see little movement at all. 2 points of the equator see no roll movement whatsoever. Pre-flood mammoths lived in a temperate to tropical region near the equator. The concentrated mass of the newly formed Himalayas caused them to drive toward the equator as Earth spun. As this happened, the entire Earth rolled, which caused some temperate and even tropical regions to end up permanently frozen as they were rolled to higher latitudes. Of course, other newly formed mountains also formed around the Earth, so the Himalayas were eventually counterbalanced by these other masses. This is why the Himalayas did not roll all the way to the equator. Many animals froze in super cold hail remained preserved as their new Arctic latitudes soon became permafrost. These animals seem to be out of place because they are out of place. This explains why so many animals recovered from the permafrost today are well preserved in spite of many evidences that they died in a temperate zone in late summer, and therefore should have experienced advanced decay. Some corroborating evidence suggests this roll happened quite rapidly, once the mass imbalance from the newly formed mountains occurred. Many see Oregon's Steens Mountain lava flows as more evidence of imagined magnetic reversals, which we've already shown to be a severe misinterpretation of the data. However, in light of the rolling surface scenario, a much different picture unfolds in the rocks on Steens Mountain. It is a case of relative motion. Obviously, the lava records movement as magnetic crystals are seen progressively oriented at steeper and steeper angles as it cooled. But what was moving, the magnetic field or the mountain? Rather than the magnetic field flipping and moving via unknown processes, we see that actually it was the pool of cooling lava which was moving rapidly through Earth's magnetic field, which continued to flow along Earth's stable spin axis. Since the lava was carried along on Earth's surface as it rolled, its magnetic components froze at different angles, recording the movements of the roll, which achieved rates of up to 6 degrees per day. There is yet more evidence of this roll and its approximate magnitude. Just south of the massive Himalayas, a peculiar 3,100-mile formation termed a progressive seamount runs almost straight and almost parallel to the 90th meridian. For this reason, it is called the 90 East Ridge. There is nothing else like it in the world. Plate tectonic theorists assume hotspots from the mantle have somehow produced this, but there is much debate over how this actually happens. In addition, plumes do not address why the ridge is so straight, nor why it aligns almost parallel with the Earth's axis of spin, nor why it is located directly south of the Himalayas. Of course, by now you should remember that since magma is compressible, plumes from Earth's outer core could never rise anyway. Hydroplate theory's concept of the big roll offers a simple explanation for the ridge. Because of Earth's spin, the Earth is not exactly spherical. Centrifugal forces cause the equator to bulge. Of course, the equatorial bulge existed before the flood and before Earth rolled. Assume the blue line represents the pre-flood equator. Assume you tied a red cord tightly around the Earth at the inclined angle shown just below the base of where the Himalayas would have eventually formed. Because of the equatorial bulge, the distance around the equator is greater than the distance covered by the red cord. Now, if Earth suddenly rolled about this spin axis, so that the red cord was now spinning at the new equator, the centrifugal forces from the inclined bulge would begin to act to reshape the surface of Earth to form a new bulge that realigned with the new equator. This would put tremendous tension on the red cord, causing it to snap. Of course, this did not happen all at once, but in a series of lesser movements over a period of time as the imbalances from the Himalayas were equalized by other newly formed chains and as the bulge moved. Let's now align our view with the area south of the Himalayas as they rolled toward the equator. As the spinning Earth progressively rolled because of the Himalayas' mass, material just above the bulge was stretched as the bulge realigned with the new equator. At a weak point far south of the Himalayas, the surface material fractured and ripped open, allowing newly melted shallow magma to expand and rise up to fill the rip. Every time the Himalayas progressed south, the already weakened material at the crack ripped a little further. Because the rip was always the first point of the greatest stress concentration, it was naturally the easiest place for the next rip to form and relieve tension. For this reason, there was not a corresponding rip in the opposite side of Earth, where the bulge was also reshaping the surface as it rolled. Just as we'd only expect the red cord to break in only one place, so too the Earth's crust ripped only at one location. So it continued to propagate northward as Earth rolled. This explains why the 90 East Ridge's formation is so straight and why it runs almost parallel to the 90th meridian just south of the most massive point on Earth's crust. The length of the rip that formed the 90 East Ridge tells us approximately how far the Earth rolled, which works out to be about 40 degrees of roll angle. If we trace a line from the ridge through the Himalayas and continue straight through to the North Pole, as shown at this angle, and then use the same distance d that we just measured to trace from today's North Pole back down the traced line, we get a close approximation for the location of the pre-flood North Pole where Central Asia is right now. Now let's take a second look at the seemingly strange findings of out-of-place flora and fauna in today's Arctic and see if hydroplate theory's explanations match observation. The pre-flood Arctic Circle that would see little sunlight would be inside the white dashed line. Notice Steens Mountain would be almost right on the pre-flood equator, almost opposite of the Himalayas, so naturally saw a good deal of surface roll as was recorded in the cooling layers, which were a product of the compression event and were still cooling as they rolled through the magnetic field. The pre-flood equivalent of the Tropic of Cancer would run along this green line. Now notice the proximity of the Axel Heiberg and Ellesmere Islands to this pre-flood tropical zone, remembering tropical plants and animals were found there. Also notice that the location of the heavy frozen forest under Prudhoe Bay and the North Siberian driftwood, all previously out-of-place findings, now readily align with their expected pre-flood latitudes. Of course, the mammoths lived in a temperate to tropical habitat, as so many evidences indicate. The antipode of the pre-flood North Pole was the pre-flood South Pole, which was located off the coast of where South America now rests. Of course, Antarctica's dinosaur fossils, coal, and oil deposits indicate a temperate climate as well, which as you can see lines up with expected pre-flood latitudes. Notice the location of Mesopotamia and Mount Ararat, the region where Noah landed and, assuming the ark didn't drift more than a few thousand miles, where he probably was living before the flood. They likely experienced little latitude change during the roll event because they were adjacent to the Himalayas, so even Noah's initial position on the pre-flood globe was optimal for limiting the extent of climatic change that he would experience. Again, we see that hydroplate theory's few assumptions combined with insightful, well-grounded scientific scenarios do a good job of explaining much evidence that is confusing and seemingly contradictory. We'll now focus our attention on ocean trenches. These features are located primarily in the Pacific Ocean, specifically concentrated in the western Pacific Ocean, and represent the deepest points on Earth. What are trenches? How did they form? And why are they mostly in the western Pacific? Plate tectonics theories, both uniformitarian and catastrophic variants, explain trench formations in the same way. The only real disagreement is over how long the process has been taking place. Uniformitarian plate tectonic theory says seafloor spreading and plate subduction represent hundreds of millions of years of time. Catastrophic plate tectonics theory says that essentially the same process occurred quickly during the flood and then slowed over time to its present rate. We see this dogmatic explanation for trenches repeated so many times by both evolution and creation proponents that many just accept plate tectonics as a fact, and the only thing argued over is how long it took. Few have considered the forces and mechanisms required for plate subduction at any speed to actually occur. Because of this, it is important to take a critical look at this popular theory. Then we will see a completely unique and much more plausible explanation from hydroplate theory. The first problem for plate subduction is getting started. Crustal plates are said to be 30 to 60 miles thick and float on the surface because they are not as dense as the mantle. This should raise eyebrows when contemplating how the edge of one plate begins to dive under another plate. Again, we'll begin by studying balance of forces. The weight of the plates is equally resisted and supported by the mantle. Pressures along this horizontal plane are relatively even. But getting a thick slab of rock to depress into the mantle means that the resisting forces in the mantle would exponentially resist any downward movement, especially when the diving plate is less dense than the material it is said to have subducted into. A similar scenario can be experienced in a swimming pool with a foam mattress. Grab an edge of the foam and pull it down below the surface. The difficulty increases as you pull down. In the pool, we provide the unnatural force needed to pull the foam under. But what force could counteract the huge resistive forces in the mantle while a 30 to 60 mile thick plate drops under another? With plate tectonics, equally artificial forces are imagined. Plates are said to have become cooler and denser so as to initiate a dive. Also, the mantle is pictured as a viscoelastic material in spite of much seismic evidence that it is solid, which makes the problem even more difficult to explain. Catastrophic plate tectonic theorists speculate that as the flood began, the edges of the plates suddenly dropped in temperature by more than 700 degrees Fahrenheit, while at the same time the mantle softened so the cold, dense plates could sink. This is all very convenient and perhaps makes their computer simulations give the answer they were looking for. But as a mechanical engineer, this heat transfer scenario baffles me. I don't see what could cause such a large mass to get that cold, nor how it could stay that cold while diving through much hotter material. When questioned as to how this could happen, the lead promoters of catastrophic plate tectonics have yet to provide any verifiable justification. Another problem is that the strength of crustal rock can support a vertical surface that is only 5 miles high, yet these plates are estimated at 30 to 60 miles thick. So the material of the overlying plate would deform and push into and against the diving plate. The shear strength of this material would have to be overcome by the diving plate as well. The sediments that are found in trenches are layered, and the layers are not disturbed. But if movement has been occurring due to a diving plate, these layers should show signs of disturbance and folding over on themselves in the direction of movement, but this is not observed. Even if a plate did manage to dive under an overlying plate, the weight of the overlying plate would scrape away anything that was not an integral part of the plate itself. Subduction proponents often imagine ocean sediments and water being dragged down along with the plate, but the pressures between the rock at these great depths would not allow this loose sediment and water to dive against a rising pressure gradient. Of course, plate tectonic theory needs water to be dragged down by the plates because this is the theory's mechanism to explain magma chambers and why volcanoes release so much water when they erupt. However, hydroplate theory provides a plausible explanation for both deep water and magma chambers, which does not require a diving plate, nor miraculous conditions to produce them. Of course, plate tectonic theories also need sediments to disappear back into the mantle because if they were scraped off and piled up for hundreds of millions of years, no trench would exist. Diving sediments on a diving plate is failed logic from a failed idea. Another problem that is never addressed is that we are always shown a perfect straight-line subduction scenario. Only 2D section views are shown or discussed in any detail. But trenches where subduction is supposed to be occurring are curiously arc-shaped. When movement along the realistic arc shape is considered in 3 dimensions, subduction looks very unlikely. If scrutinized properly, this should raise some fundamental questions about the subduction theory versus basic observation and known material mechanics. Whether the material is rock or a piece of cloth, the geometry requires the same conditions if a plate is diving at an angle. If the plate is diving along such an arc, the material must be converging as it moves. Yet the material evidence of this convergence is completely missing along with any mechanical explanation for why the convergence is occurring. The 2 sets of black lines represent vectors of movement of the subducting plate. The arc requires that these vectors be angled with respect to each other, so there must be both a forward and a lateral component to the movement. This lateral component should be compressing, folding, crushing, and thickening the plate as it converges. A similar problem exists if the arc is oriented in the opposite direction. All trenches have an arc shape. True subduction could only occur if a plate is diving along a straight line, but of course, many other forces and features of trenches show that subduction has not occurred. Dr. Brown lists 17 specific reasons for this. Plate tectonics is a myth. The topography of plates diving in front of arced trenches should have a radial pattern of folds or mountainous chains in the compressed plate radiating out from the trenches. Yet these are absent from the seafloor. Trenches many times are linked in a repeating arc cusp pattern. 2 adjacent arcs mean that the plate is diving toward 2 separate points. The lateral components of these separate movements should be tearing the plate apart, or at least show signs of dramatic thinning as the material dives in 2 separate directions. Consider the arc cusp trenches east of Japan. If the oceanic plate is diving down, then it has to be diving in several directions at once. Likewise, there should be rifts or valleys indicating the plate is tearing apart as it separates. Yet again, the topography on the seafloor shows no evidence of this movement of the plate in different directions. Finally, let's assume a plate has successfully plunged into the mantle to a typical depth cited by proponents of plate tectonics. We'll just look at a first-order analysis of forces involved with even a perfect world plate diving along a straight line in a 2D scenario. Green arrows represent forces that will allow the plate to dive further into the mantle. Red arrows represent forces that prevent movement into the mantle. Red and green arrows are in a tug of war, and the question is, which one would we expect to win? First, sum the green dive forces that would allow further penetration into the mantle. Let's just set the width along the plate to 1 centimeter. We'll again give plate tectonics the benefit of the doubt by assuming no tension crack forms as the material bends down. This will allow the highest possible loading of the plate to support a dive. Assume the plate is evenly pushed into the mantle at the material's maximum compressive strength. It is physically impossible to compress higher than the max compressive stress, as it would crush the plate rather than transfer load to the diving portion of the plate. Then we'll add the component of the plate's weight that would pull it deeper into the mantle. Plug the numbers into the equation and we get 515 billion newtons per centimeter, which works out to 116 billion pounds of force. Now sum the red restrictive forces, which consist of friction above and below the plate, plus whatever head-on restrictive forces are acting in front of the plate. First, be generous and ignore the resistive forces in front of the plate, since we don't know the shape anyway. Now we'll just sum the frictional forces above and below the plate, and again plug the numbers into the equation and we get 16.5 trillion, not billion, but trillion newtons per centimeter, or 3.7 trillion pounds per centimeter. Now let's compare the results. Obviously, the red forces easily win the tug of war. Friction forces alone are over 30 times greater than the subductive forces. A plate cannot subduct. Questioning if the mantle could be viscoelastic is highly imaginative, but is also highly unlikely based on all the seismic evidence that it really is solid. Any explanations of lubrication suffers from then having to explain the origin of the lubricant. Something is wrong with plate subduction theory, and as more information is collected, the evidence against plate tectonics and mantle convection continues to mount. So much so that I was surprised to see this admission in Wikipedia's plate tectonics page. Clearly, trenches are deformations of Earth's surface. Therefore, understanding trenches should first begin with understanding the failure mechanisms of the material and recognizing how any of them deform. Pausing to do this is essential to reaching correct conclusions when performing a material failure analysis. For engineers anyway, skipping these steps and injecting a preconceived idea usually results in frustration and many hours wasted trying to validate an alleged failure mode. So first we should consider what forces could cause a spherical shape to deform in such a manner that its surface deforms into an arc and cusp shaped pattern as we see in trenches. Ping pong balls help us see that either an external force like my thumb or an internal force which causes the surface to collapse inward will readily produce the characteristic deformation we are interested in investigating. An external force is very unlikely, so the force that caused the western Pacific surface of the Earth to collapse or subside must have come from inside the Earth. One important clue is to realize that the western Pacific antipode is the middle of the Atlantic Ocean. So if you were to dig a straight hole from the middle of the western Pacific, about which the trenches are concentrated, through the center of the Earth, you'd exit in the middle of the Atlantic Ocean. I'll also point out that obviously, looking at the map, we see the arc-cusp deformation lines are not closed pattern as with ping pong balls. However, notice that the mid-oceanic ridge runs diagonally across the southern end of the Pacific Basin. Remember that the mid-oceanic ridge is a series of deep tension cracks that were already fractured by the time the forces on the Pacific plate to the north were acting. So this portion of the plate and mantle had already failed, so the characteristic arc and cusp chain did not deform in this location. Here's a better view using a globe. A straight line through the center of the Earth at the red push pin exits the Earth in about the middle of the Atlantic Ocean. Let's go back to the graphic we first used in describing how the Atlantic seafloor rose up, causing a chain reaction which led to much movement and the melting of the inner Earth. We'll quickly review. As the Atlantic floor buckled and rose up, it could only move by shearing, which produced friction and heat. As shearing continued at greater depths, the heat generated melted the shearing surfaces. Once melting occurred, this caused a runaway cycle of contraction and shifting and more melting. The direction of shift was always toward the rising Atlantic floor as more material shifted toward the contracting magma. We will now examine the effect these forces had on the opposite side of the Earth, which we've just seen happens to be the western Pacific seafloor. What was felt as pushing up for the Atlantic was felt as pulling down for the Pacific. Eventually, the Pacific hydroplate subsided and collapsed in on itself as it and the mantle both sheared and were fractured, creating many deep faults in this area of the mantle. As the central portion of the Pacific plate and mantle subsided, it sheared diagonally away from the surrounding material. The Benioff zones that plate tectonic theorists believe to be diving plates are actually the result of another well-known failure mode studied in material mechanics. When a finite element is placed under stress, its principal stresses, represented by the yellow arrows, cause the material to experience shearing forces, represented by the blue arrows. If the material fails in shear, the angle of the shear plane, represented by the black line in the square element, forms roughly 45 degrees from the element's principal stresses. For the mantle, the principal stress directions were toward the rising Atlantic and toward the center of the collapsing Pacific plate. Therefore, it sheared diagonally downward, forming a shear plane, which so many mistakenly believe is a diving plate. If interested in more detail of why materials shear in this way, study an engineering material mechanics textbook, focusing on the chapter describing Moore's circle. Or if you just want to see it happen, take a piece of chalk and twist it without bending, pulling, or compressing it, and you'll see that it shears spirally along a roughly 45-degree plane. For a time, the Earth's shape became very irregular. The movement of such large volumes of Earth's surface would have greatly affected the atmosphere as it rushed in to fill the sudden void, causing a sustained wind due to the sudden low pressure in the Pacific. This is likely why Genesis 8:1 records a great wind passed over the Earth. Because the Earth is not a tiny ping pong ball, its gravity eventually pulled it back into a scarred yet spherical shape. The deep arc-and-cusp-shaped surface scars are seen today as ocean trenches. We will now focus on the heavily fractured central portion of the Pacific mantle and plate because this region is key to understanding why continents are slowly moving today. Plate tectonic theory presents Earth's surface as covered with many floating plates shown here with red arrows indicating each plate's movement based on its main tenets, that the seafloor is spreading at the mid-ocean ridges where the new crust is being made while older crust is diving under adjacent plates at ocean trenches. As you can see, many times edges of some plates are shown to be moving perpendicular to each other. If this is correct, seismic data collected of continental shift should validate this chart. Interestingly, the data does not support this at all. Rather, most earthquakes around the Earth indicate surface shift toward the western Pacific region we've been discussing. As stated, the Pacific hydroplate and mantle below were severely fractured as they collapsed and subsided. This exposed many deep fissures to the surface, and magma above the crossover depth spilled out en masse over the face of the Pacific plate, which essentially buried it under the expanding rising magma. The Western Pacific has over 40,000 underwater seamounts that are at least 1 kilometer high, or 0.6 miles high. That's the highest concentration of volcanic seamounts on Earth. This dense population of volcanic mountains is compelling evidence of a great deal of deep fractures in the mantle below. In many places, the magma continues to be produced along the deep faults and continues to rise and spill out, forming huge underwater volcanic mountains. Some have risen above sea level, forming many Pacific island chains like Hawaii. We will now discover the mechanism behind why almost all earthquakes shift the mantle's mass toward the fractured western Pacific region. Watch the thin white lines which represent how the mantle moves as magma is produced in a fault and then is distributed. For any deep sheared fault, magma produced along the fault that is above the crossover depth will rise and expand the upper portion of the mantle as it climbs. These properties of magma explain why the number of earthquakes at specific depths varies the way that it does. Most earthquakes are shallow and occur well above the crossover depth. This is because magma is expanding as it rises. Near the crossover depth of approximately 220 miles, there are significantly fewer earthquakes because magma produced at this level is the same density as the surrounding solids, and therefore does not tend to move up or down and cause earthquakes. Below the crossover depth, we see a second peak in the number of earthquakes. Again, this is because magma is on the move, only headed down to Earth's outer core. However, because the crossover depth for magma is only about 220 miles below the surface, for any fault filled with magma, there is over 7 times more magma below the crossover depth than above. As magma is compressed and falls toward the Earth's outer core, its volume reduces, and the overall effect is that the mantle as a whole shifts toward the fault. It is a case of volume out must equal volume in. If deep faults were spread evenly around the Earth, we'd expect somewhat random mantle shift directions. However, most deep faults are concentrated in the western Pacific region as indicated by the tremendous amount of volcanic activity. Only hydroplate theory explains why this is, and why the mantle today slowly shifts toward this region. As magma is produced over time along these many faults, it either rises up to the Pacific floor or falls down to the outer core. Again, the driving mechanism is gravity. As volume leaves the mantle in this area, the mantle must shift toward this region to fill the void. This map of actual seismic data shows this general shift toward this region of the Western Pacific. Only hydroplate theory explains why this shift occurs and why it points to the Western Pacific. Of course, as earthquakes occur, scientists can now measure slight changes in Earth's rate of spin, which generally spins faster with each large quake. This is because most magma produced is basically mass that is being compressed and moved toward Earth's spin axis as it travels to Earth's liquid core. Why this happens is explained by the law of conservation of angular momentum. Consider the technique of a figure skater in a spin. Arms and free leg enter the spin outstretched. The mass of each will be represented by the letter m. To increase the speed of their spin, the skater slowly pulls their limbs close to their body. If inertia decreases due to the movement of mass toward the axis of spin, angular velocity must increase for angular momentum to be conserved. Test this yourself the next time you are in an office chair. Hold your arms out and have someone spin you, then pull them in and you will see the increase in speed. Remember, according to hydroplate theory, before the flood, Earth's diameter was slightly larger than today, and its core was not liquid. You probably notice after reading the flood account that months are tracked in exactly 30-day increments. This is common among ancient cultures. In fact, most held to a 30-day month and a 12-month 360-day year. It is curious why they all chose the number 360 if a year has always been 365 and a quarter days. However, if, as the Genesis flood shows, all these cultures were descended from Noah and his sons, then it makes sense why they would all think a year was 360 days. That is what Noah and his family knew a year to be before the flood. However, the many changes that occurred since the flood have increased Earth's spin rate. If a day was only 21 minutes longer, a year would match the ancient 360-day calendars. Because observation did not match what was assumed to be a year's time, we see that many cultures had a keen interest in tracking a year by tracking the stars. It must have been very puzzling why a year's length changed. This may be confusing, so I find this simplification helps. Instead of 360 versus 365 days a year, let's just say a year pre-flood was only 4 days long. Because the mass shifted to Earth's center, the angular momentum increased and caused the rate of spin to increase, just like our figure skater example. Note that the velocity of Earth's orbit around the Sun did not change, only Earth's rate of rotation about its own spin axis. In our example, let's assume that post-flood, the rate of spin increased from 4 days to 6 days per year. As Earth's core temperature increased from shifting of materials, the mantle materials with the lowest melting point melted first. As these low melt materials became liquid, crystals of materials with higher melting points became suspended in the melt, but not for long. Gravitational settling began immediately. Dense crystals whose mass was mostly iron and nickel gravitationally settled toward Earth's center. These began forming Earth's solid core. Many of the iron crystals were magnetite. As the magnetite fell through the liquid core to Earth's center, these magnetic crystals were free to align with Earth's magnetic field. This is why Earth's magnetic field is now so strong, and also why seismic waves pass through the core faster when traveling along Earth's magnetic poles than they do when passing in a perpendicular direction. Because the settling magnetic crystals were free to align and tended to align in the same direction, the inner core grew to become a giant magnetic iron-nickel crystal. Unmelted material in the magma, which was less dense than the magma, floated away from Earth's center and rose up until it contacted the bottom of the remaining solid mantle. This slurry mixture of magma-filled sediments became the ultra-low velocity D double prime zone at the base of the mantle, where seismic waves cannot travel quickly through the matrix of both solids and liquid. Because most magma produced was well below the crossover depth, it was compressed to 50% of its original volume. Because of this, Earth's radius has been reduced since the flood. Today, the Earth's average radius is 180 miles less than it was before the flood. The mantle and crust were forced to compress, causing further buckling at the surface, forming additional mountains as Earth's volume decreased like the wrinkled skin of a drying apple. Now that all this has been explained step by step, and by now you've heard and seen much of the explanation and the main points of the hydroplate theory, we can now look at an animation which shows almost everything happening in time. Again, Earth's gravity is the primary driver. This short animation begins as the plates have first split. The sides are eroded away by the fountains. Some critics claim the hydroplates could not have slid because they would have run into each other. Here you can see the erosion of the plates left plenty of room for the initial movement because the perimeters were eroded by several hundred miles on both sides of the crack. Next, the floor of the mantle buckled up, forming the mid-oceanic ridge, beginning in the Atlantic. This lifted the African and American plates as the Atlantic seafloor rose up. Material sheared deep in the earth as the Atlantic floor rose. Near the core, even microscopic movements caused surfaces to melt. The deeper this occurred, the more and more adjacent material also sheared and melted. By the time this reached the western Pacific, the region of shear and subsidence spanned a wide area, and the entire Pacific plate collapsed and subsided with the fractured mantle as it shifted toward the rising Atlantic floor. This continued and intensified as melted materials in Earth's core contracted, slipped, and melted in a runaway process. Of course, contraction of the core caused contraction of the mantle as well, so while the Atlantic floor was pushing up on the Eurasian, African, and American plates, the mantle was contracting and falling away on the opposite edge of the plate. The plates easily slid down and away from the rising ridge on the remaining lubricating water. The rapid movement soon ceased as plates ran out of water and ground into the dry rock of the mantle, crushed and buckled up, forming compressed mountain chains, while melting much of the rock between the sliding surfaces. Now we can see a second reason the plates could more freely drift. Most of the Pacific plate was pulled down out of the way. The collapsed plate had so many fractures that magma rising from the heavily faulted mantle below spilled out on top of and covered it. So the Pacific plate was pulled down and buried in basaltic magma at the same time. Some 40,000 seamounts formed in the western Pacific above the many fractures. Heat from this magma warmed the oceans for centuries, providing the necessary conditions, along with high continents that had yet to sink into the mantle, to actually start and maintain Earth's only actual ice age. Once these required conditions ebbed, the ice age also ceased. As the core melted and contracted, Earth's volume was reduced by about 180 miles radially. Unmelted sediments in the core settled gravitationally as well, which formed the iron-nickel solid inner core, and the slushy ultra-low-velocity D double prime layer at the mantle's base. Let's replay once more to view all at once. Let's now review the main events in the Genesis record in light of the topics we've covered in the hydroplate theory. The flood begins on the 17th of the second month of Noah's 600th year, with the catastrophic rupture of Earth's granitic shell. Deep interconnected chambers of water burst out as great fountains from the deep. Heavy rain falls from the fountains for 40 straight days, then suddenly stops even though the waters continue rising. In the early stages after the rupture, some regions of Earth are buried in supercold hail and muck, trapping, freezing, and preserving mammoths and many other plants and animals. At the same time, Earth's hydroplates are fluttering from the powerful horizontal flow of the ocean of escaping water below. The resulting pressure waves in the granite's quartz produces huge voltages which arc within, producing focused nuclear fusion and fission events, which birth Earth's heavy radioactive elements. The chaotic environment filled with many high-speed subatomic particles bombard the new, fragile heavy nuclei, greatly accelerating their decay rates. The heat generated greatly accelerates the flow of the escaping fountains. Some materials swept up in the violent hypersonic flow of the pulsing fountains are accelerated to such high speeds that they escape Earth's gravitation. An ocean of water, rocks, minerals, gases, dust, and organic remnants are blasted from Earth into the solar system, eventually becoming what are now observed as comets, asteroids, meteoroids, and trans-Neptunian objects. Floodwaters continue to rise even though the rains have stopped, as subterranean waters continue to escape from below. Plants and animals are buried in the muddy waters and eroded sediments. Repeated liquefaction of sediments produces stratified layers in which buried animals and plants are sorted into a sequence that some today mistakenly claim was produced by millions of years of evolution. After about 150 days, the hydroplate's perimeters have been eroded hundreds of miles and have thinned, forming continental shelves and slopes. The mantle floor can no longer support the imbalance from the missing material and bulges up, producing the mid-oceanic ridge. Rapid continental drift begins as plates slide away from the rising mantle floor. Soon the plates crash into the mantle floor as they run out of the lubricating water below. The compression event crushed and thickened the hydroplates and formed mountain chains. As that land thickened and rose, the floodwaters drained into very deep ocean basins. Much of the world's buried plant life is compressed and heated, forming many coal and oil deposits. The big roll of Earth's surface begins. After 150 days, the Ark comes to rest on a newly formed mountain rising out of the waters. Meanwhile, the rising Atlantic seafloor causes shearing far below, and Earth's core begins melting and contracting as it extrudes toward the rising Atlantic. The Pacific hydroplate on the opposite side of Earth is pulled deep down under miles of rising magma, which is expanding up from the crossover density boundary. The Pacific seafloor is then covered in volcanic seamounts. A great wind is observed as the atmosphere adjusts to the subsiding Pacific plate, and ocean trenches are produced by the deformations. For centuries afterward, heat from the rising magma warms the oceans, greatly increasing evaporation rates. That, in combination with the newly formed continents yet to fully sink into the mantle, cause Earth's first and only ice age. 74 days after landing on Mount Ararat, surrounding mountains finally become visible. Noah begins sending birds out in regular 7-day intervals, observing their behavior. After 314 days since the flood, land is fully visible. Noah uncovers the Ark. Apparently conditions are still too unstable to exit. Finally, 57 days later, after 371 days since the rupture, the land is dry and stable enough for all to exit the Ark. Unbeknownst to Noah's family, the melting inner Earth is gradually increasing Earth's spin rate. The 360-day calendar they've used to chronologically track these events will soon be obsolete and confuse many generations of their offspring. As the newly formed mountains slowly settle into the mantle, frictional heating melts rock, generating magma. The magma is then injected under the adjacent crust, causing the weakest portions of the crust to fracture and rise to become plateaus. As the thickened continents sink into the mantle, the initially deep ocean floors rise to today's level in compensation for the downward flow of mass. Of course, sea levels rose with the ocean floors, and the continents were divided by water in the days of Peleg. That concludes this overview presentation of hydroplate theory. Hopefully this has been helpful in bringing visual clarity to some topics which can be rather difficult to conceptualize. I'd like to thank Dr. Brown for reviewing this material and providing many inputs which improved the end product. For more information, details, and reference materials, I highly encourage you to visit the Creation Science webpage listed here.